The first sound is not thunder. It is a roar of water somewhere beyond the horizon, a wall of ocean rising where no sea should be, turning midnight into a sheet of white fire as something tears across the sky. Imagine standing there, on the last day of a forgotten world, watching constellations fall like burning snow and knowing your entire history is about to be erased. Tonight on Moonlight Science, we follow the scattered fingerprints of that erasure, a 30,000-year gap in our story that science still struggles to fill, where myths speak of gods and floods and rocks whisper of comets and fire. And at the end of this journey, when we place the last missing piece, we will return to a single date on our calendar and see it differently forever. Before that sky ignites, the world is cold and slow and ancient. It is the late Ice Age, and the northern hemisphere is pinned beneath walls of ice so vast they bend the crust of the planet. Glaciers a mile thick grind across what will one day be Canada and Scandinavia, their blue-white faces creaking forward in the silence of 10,000 winters. To the south, endless grasslands ripple under a hard, clear sun. Herds of mammoths move like living hills across the steppe, tusks curling toward a sky that has never known a city. Giant ground sloths heave themselves through scrub forests. Saber-toothed cats wait in the long shadow of boulders, their breath a mist above frozen earth. Humans live here too, small bands scattered along river valleys and the edges of the ice. Their world is measured in the flicker of firelight against stone, in the crunch of snow under worn leather, in the story told quietly after the hunt. They know the constellations as hunters and beasts, lovers and enemies. They know the seasons as shifts in wind and light. The time when the mammoths move north, the time when the rivers lock under glass, the time when the sun never climbs high enough to warm the bones. On this night, one such group shelters in a shallow cave overlooking a wide, dark plain. The fire pops, resin cracking in the resinous wood. Children drift toward sleep. An elder traces the outline of an aurochs on the cave wall with a blunt finger, planning tomorrow's painting. Outside, the wind is steady and cold. The stars are cruelly bright. Then one of those stars moves. At first, it is nothing, a smudge of motion in the corner of the eye. A hunter at the cave mouth squints, frowns, trying to resolve it. A spark low on the horizon, too bright, too fast. It grows as he watches, swelling from a pinprick to a bead, from a bead to a burning coal. The color is wrong, more white than yellow, edged in unnatural blue. Shadows behind him lengthen and sharpen. The cave seems to twist around that rising light. Far beyond his sight, something ancient and shattered is intersecting Earth's path. A fragment of a comet, perhaps one of thousands, plunges into the upper atmosphere at tens of kilometers a second. Air, unable to move, aside, compresses in front of it, heating instantly to thousands of degrees. The ice-crusted rock is wrapped in a sheath of plasma, the air itself turned to luminous fire. To anyone beneath, it looks as if a second sun has been born at the edge of the world. The hunter shouts. People scramble to the cave mouth. Night is gone. The plain outside is lit as if by noon, every blade of frozen grass was casting a shadow. Mammoths trumpet in panic, silhouettes rearing against the blazing sky. Birds explode from the reeds along a distant river, a dark, frantic cloud. The light grows unbearable. Eyes water, arms rise to shield faces. The burning object swells, and then, in an instant that will echo in dreams for generations, it splits the sky. There is no impact thud, no cinematic boom. First, there is silence, a vacuum of expectation. The comet fragment, meeting denser air, destabilizes and detonates high above the ground. In a sphere the size of a mountain, air is flash-heated to the surface of the sun. The rock itself vaporizes. A dome of incandescent gas and molten droplets blossoms overhead. Then the shock wave hits. It arrives as a wall of pressure that rips breath from lungs and thoughts from minds. The forest between the cave and the horizon does not bend. It lies down, trees snapped like grass in a scythe's path. Branches become spears, leaves turn to shrapnel. The fire in the cave is snuffed in an instant, replaced by a hot, dry wind that smells of burning sap and singed hair. On distant bodies of water, that same shock front slams into the sea, punching it down, then letting it spring back as a vertical wall. Waves rise, race outward, run up river valleys that have never seen tides. Shorelines vanish in spray and noise. To those on the coasts, it feels as if the ocean has decided to stand up. From the burning air above, glass begins to fall. Sand and soil flash melted into droplets by the explosion, cool and harden as they drop. Tiny beads of green and brown that hiss into snow, into skin, into the still smoking stumps of trees. Farther away, where the heat is less intense, embers and ash drift down in a gentle, deceptive rain. Black snow, carrying the scent of entire forests, set aflame at once. In the hours that follow, fires join into firestorms. Columns of hot air twist upward, feeding on themselves, creating their own winds. Animals flee, then stumble, then simply lie down as smoke takes the sky. The sun, when it finally rises again, is a dull, angry disk glimpsed through a red-brown veil. For the people in the cave, nothing will ever be the same. Those who survive this night emerge into a world subtly but permanently altered. Rivers clogged with debris, grazing grounds charred, familiar paths erased. They have no words for airburst, no equations for thermal radiation, but they have eyes and memories. Around future fires, they will reach for metaphors big enough to hold what they saw. The sky opening, the gods throwing, stones, the heavens leaking fire. They will speak of days when water climbed the mountains and when the sun was taken away. Those stories will be told and retold, braided into origin myths and warning tales, carried across continents with migrating peoples. Millennia later, when cities rise where ice once lay and astronomers aim instruments at the same sky, we will find their faint reflections in cuneiform tablets, in sacred texts, in legends of world-ending floods. Somewhere in that overlap between rock and story lies our central mystery. Not just that the sky once caught fire, but that something in us refuses to forget. For a long time, scenes like that night of fire were treated as the stuff of legend, not history. The official story of us was cleaner, simpler, and far more comforting. In that version, humans emerge from Africa as clever apes, with stone tools, slowly spread across the globe, gradually learn to farm, and then, only a few thousand years ago, begin stacking stones into ziggurats and writing laws on clay. It is a story of continuous ascent, of a line that rises more or less smoothly from hunter-gatherer campfires to modern cities. But when you start to examine the record with a forensic eye, that line breaks. Instead of a steady slope, you find missing chunks, jagged jumps, and long, strangely quiet plateaus. You find stone tools that appear, flourish, and then disappear as if an entire way of thinking ended. You find symbols and art that erupt in complexity, then seem to vanish, only to reappear thousands of years later in different forms. And in our own DNA, you find signatures of narrow squeezes, times when the entire human population shrank to a fraction of what it once was. Somewhere inside those irregularities lies a 30,000-year history gap that we are only beginning to see. Walk into a cave in southern France or northern Spain, and you step into that gap. On the walls, painted in ochres, blacks, and whites, are horses with muscles perfectly suggested by a single stroke, bison in motion, lions staring out with an unnerving sense of presence. At Chauvet, at Lascaux, at Altamira, these images are so sophisticated they can still move you across a gulf of 30 or 40,000 years. These are not crude doodles scratched by barely cognitive primitives. They are the work of people who understood anatomy, perspective, and movement. People who knew how to turn flickering firelight into part of the experience, painting in curves and niches so that animals seem to breathe as the shadows dance. Some of these paintings are older than agriculture, older than the first cities by a period of time, longer than all of recorded history. Then you step out of the cave and back into the timeline, and something strange happens. For tens of thousands of years after those first great bursts of symbolic art, the archaeological record looks, on the surface, almost monotonous. Stone toolkits shift subtly from one region to another. But there are no cities, no writing, no metal, no obvious monuments. It is as if the mind that could paint Chauvet went back underground and slept. Tools tell a similar, unsettling story. In parts of Africa, finely worked stone points and blades, tiny microliths that could be set into shafts to create complex composite tools appear in layers dating to around 70 to 60,000 years ago. They suggest planning, standardization, perhaps even specialized roles within bands. Then in some regions, those technologies decline or vanish, replaced by simpler, cruder implements. In Australia, where humans arrive at least 50,000 years ago, we see early evidence of complex behaviors: seafaring, landscape management by fire, long-term use of rock shelters, but no obvious progression to cities or state-level societies even after tens of millennia. It is as though humanity rehearses certain capabilities, then abandons them, then rediscovers them again much later. Our genomes add another piece to the puzzle. When geneticists reconstruct our demographic past, they see not a smooth expansion from a single small tribe to 8 billion, but repeated contractions. There are times when the effective population size of Homo sapiens drops dramatically, bottlenecks where perhaps only a few tens of thousands of breeding individuals remain worldwide. Some of these may correlate with known events: super eruptions, sudden climate shifts, periods of intense drought or cold. Each bottleneck acts like a filter, pruning branches from the tree of our ancestry, compressing cultural diversity as well as genes. Imagine what that means in lived experience. Entire language families extinguished. Rituals and stories carried by only a few survivors. Skills lost because the one person who knew how to nap a particular kind of blade or track a particular animal died in the wrong winter. Again and again, the evidence hints at resets and stalls. Even when we come closer to the familiar threshold of civilization, the pattern persists. In Europe around 40 to 35,000 years ago, an explosion of ornate tools, musical instruments, beads, and carvings appears with the so-called Aurignacian culture. Within a few thousand years it is gone, replaced by other traditions with different toolkits and styles. In Siberia, in the Levant, in East Asia, archaeologists find sophisticated local cultures that flourish and then fragment or disappear. If all you had was the standard story, a simple line from caves to cities, you might be tempted to smooth these bumps away as noise. But when you line them up, when you place the cave art beside the bottlenecks, beside the disappearing tool traditions, beside the oscillating climate curves, a different picture emerges. one less like a gentle ramp and more like a staircase built in the dark, with steps missing, edges crumbling, and entire flights ripped away. This, then, is the heart of our mystery. Somewhere within a 30,000-year span, human behavior keeps stuttering, leaping forward in bursts of creativity, falling back, changing direction as if pushed and pulled by forces beyond simple cultural drift. Long before Sumer, before Egypt, before any priest etched a god's name into stone, there were already cycles of innovation and collapse. The question that haunts this gap is simple and ominous. Why? Was it only the slow grind of ice and drought, the ordinary brutality of nature? Or were there moments, like that night when the sky caught fire, when the entire board was knocked over, forcing our ancestors to start again with whatever pieces they could salvage? As we move deeper into this investigation, we will follow the clues left in mud and ice, in bones and genes, to see whether those broken steps in our timeline align with scars carved not by human hands, but by something that came from far beyond our world. To trace those scars, we have to leave the comfort of stories and step down into the earth itself. Picture a dry arroyo in New Mexico, a riverbed in South Carolina, a windswept plain in Belgium, a lakeshore in Syria. On the surface, they could not be more different. Different climates, different histories, different modern cultures breathing above them. But if you dig carefully through their sediments, peeling back the centuries layer by layer, something uncanny begins to appear. Far below our cities and farms, below the traces of medieval fields and Roman roads and Neolithic hearths, the soil turns into a slow archive. Each distinct layer is a year, a decade, a century of wind-blown dust, flood deposits, fallen leaves, and the quiet settling of microscopic shells. Geologists read these strata like sentences, each texture and color a different clause in the story of a place. And then, in site after site across 4 continents, they reach the same unsettling punctuation mark. It is a band only a few centimeters thick, sometimes jet black, sometimes dark and greasy, sometimes shot through with tiny flecks that glitter under the right light. It drapes across ancient river margins, mantles old lake shores, lies like a dark ribbon between brown and tan. Above it, the bones of deer and bison, the tools of later hunters, the pollen of forests more familiar to us. Below it, the remains of mammoths and mastodons, saber-toothed cats and giant ground sloths, and the artifacts of the people who hunted them. This is the black mat. At first, it was just a descriptive term. Archaeologists in the American Southwest began using it decades ago to refer to these dark, organic, rich layers that cap the final appearances of Clovis spear points and megafaunal bones. They thought they were seeing the remains of wetlands, marshy conditions preserving carbon-rich sediments atop older deposits. But when teams began to examine the black mats more closely, under better microscopes and with more precise dating techniques, the benign interpretation started to crack. Take a sample of this thin, dark horizon and grind it down. Under the scanning electron microscope, the mat is not just soil and decayed plant matter. Embedded in it are tiny glassy droplets called spherules, perfectly rounded beads of once molten material. Their surfaces are pocked and frosted in ways characteristic of rapid cooling as they fell through the air. Mixed among them are other, even stranger shapes. Shards of glassy carbon, twisted, contorted, as if organic material had been flash-heated to extreme temperatures and then frozen in place. Look closer still, and you find nanodiamonds, crystals of carbon only billionths of a meter across. On Earth, such formations do not occur in any great abundance at the surface. They are made in laboratories, in the deep mantle, or in places where shock pressures are so high that ordinary carbon is squeezed into this tightly packed form, in the blast zones of nuclear tests and in cosmic impacts. Alongside these, measurements show spikes in elements like iridium and platinum in the black mat. These metals are rare in Earth's crust, but relatively common in asteroids and comets. We know this pattern well from another disaster. The layer that marks the end of the dinosaurs 66 million years ago, enriched in iridium from the Chicxulub impactor. Here, though, the layer is much younger. Radiocarbon dating of organic material bracketing. The black mats converges on a narrow window around 12,800 years ago. In Greenland ice cores, that same moment shows up as a sudden shift in oxygen isotopes, temperatures plunging back toward glacial values. Pollen records across Europe and North America register forests dying back, tundra species advancing. It is as if the climate system flips a switch. The alignment is eerie. In the sediments, a dark line full of burn scars and cosmic signatures. In the ice, an abrupt cooling at the very onset of what we now call the Younger Dryas. A 1,000-year relapse into cold just as the planet seemed to be warming out of the last ice age. In the bones, the last appearances of many megafaunal species. In the archaeological record, the fading out of the Clovis people. If this were a crime scene, the black mat would be the tape marking where the bodies start. Not everyone agrees on the cause. Some argue these features can be explained by ordinary wildfires, by marsh formation, by processes we already understand. Others, however, point to the specific combination of charcoal, melt glass, spherules, nanodiamonds, and platinum spikes as a signature of something more violent. A rain of fragments from a disintegrating comet exploding over the ice sheets and continents. Either way, the black mat speaks in a language of ash and glass. It tells us that around 12,800 years ago, the world did not simply drift into a colder phase. Something punctuated the climate, burned landscapes on a continental scale, and drew a dark, thin line between the age of mammoths and the age of memory. And that line, replicated in riverbanks and lake beds thousands of kilometers apart, hints that the trigger did not rise from the oceans or the deep earth. It fell from above. The black mat is only a few centimeters thick, but when you line up its age in dozens of sites, it marks the beginning of one of the most violent mood swings Earth's climate has ever recorded. To see it, leave the riverbanks and dive, in your mind, into the heart of an ice sheet. In Greenland, 2 miles of ice lie stacked like pages. Scientists drill down through it, hauling up cylinders of frozen time, cores streaked with annual layers as clear and regular as the rings of a tree. Each layer traps bubbles of ancient air, dust from distant deserts, ash from volcanoes, and in the chemistry of the ice crystals themselves, a record of temperature. Slice through the section that spans 13,000 to 11,000 years ago, and what you see on a graph looks less like a gentle curve and more like a cardiogram in distress. The line that represents temperature is climbing as the last ice age loosens its grip. Then suddenly, it drops. Not gradually, not over millennia. In some reconstructions, average temperatures in parts of the North Atlantic region fall by as much as 10 to 15 degrees Celsius in a matter of decades, perhaps within the lifetime of a single human being. This cold interval is what we call the Younger Dryas, named after a hardy Arctic flower, Dryas octopetala, whose pollen suddenly reappears in European sediments from that time. Before the onset, forests of birch and pine had begun to creep north, following the retreating ice. Lakes once locked under glaciers sparkled in the summer sun. human groups adapted to this new, relatively stable world, tracking game across increasingly predictable landscapes. Then, in the space of a few generations, that progress reverses. Where forests had been, steppe and tundra return. Tree pollen in lake cores dwindles. The stubborn Dryas flower's pollen surges, marking a switch back to a cold, open environment. Rivers that had been roaring with meltwater quiet as the great ice sheets stop receding, some even re-advancing. In some regions, permafrost deepens again. The line between habitable and lethal shifts south. For the people living through it, there are no graphs, no isotope ratios, no Latin names. There is only weather that no longer follows the old patterns. Winters lengthen and bite deeper. Summers shrink. Animals that had begun to expand their ranges retreat or die. The predictability that had nurtured experimentation, with new tools, with more settled ways of life, evaporates. From the perspective of modern climate science, the Younger Dryas is an alarm bell. When researchers first realized, in the late 20th century, just how abruptly temperatures had swung at its onset and end, the revelation shook a field that had long favored slow, stately changes. Here was proof in frozen water that Earth's climate system could flip states like a switch, not just slide gently from one regime to another. The details come from the ratios of oxygen isotopes, atoms of oxygen with slightly different masses, locked into the ice. Warmer conditions favor slightly higher proportions of the heavier isotope, oxygen 18. Colder conditions skew toward oxygen 16. Plot those ratios over time, and you get a temperature curve. In the Greenland records, the Younger Dryas looks like a jagged canyon, a plunge into cold, a long, jittery stay, and then an equally abrupt climb out around 11,600 years ago. Superimposed on that canyon are smaller spikes and dips, short-lived oscillations that make the line resemble a heart in fibrillation. The climate is not just cold, it is unstable, twitchy, careening between substates as the planet's circulation systems adjust. What caused this? The safest answer is that the North Atlantic's great conveyor belt, the system of currents that carry warm water north and cold water south, was disrupted. A sudden flood of fresh water from melting ice, poured into the wrong place at the wrong time, could have shut down the normal pattern, leaving heat bottled up in the tropics and plunging the North Atlantic region into a deep chill. But that only pushes the question back a step. Why did the meltwater surge then? Why so abruptly? Why in such apparent synchrony with the black mat's burned horizon, with those impact proxies scattered across continents? Many researchers see the Younger Dryas as a purely internal lurch of the climate machine, driven by the inertia and feedbacks of ice, ocean, and atmosphere. Others argue that an external jolt, a barrage of comet fragments exploding over the ice sheets, instantaneously melting and destabilizing them, could have supplied the trigger. What everyone agrees on is the consequence. For more than 1,000 years, roughly from 12,800 to 11,600 years ago, large swaths of the northern hemisphere were thrown back into conditions barely better than full glaciation. And then, almost as quickly, the world warmed again, in a sharp climb that marks the true beginning of our current interglacial, the Holocene. The end of the Younger Dryas is as abrupt as its start. If you compress Earth's history into a single day, the Younger Dryas is a few seconds of wild convulsion right before dawn, just before humans step onto the stage of written history. Those seconds remind us that the calm evening we now inhabit is not guaranteed. The climate has snapped before, violently and without warning. and it did so at exactly the time when our species was poised to make its first fragile experiments in civilization. To explain a climate flip as fast and violent as the Younger Dryas, some scientists say we don't need to look beyond Earth. But others keep glancing upward, toward the dark where comets circle. Their idea is simple in outline and staggering in implication: that the cold snap, the black mat, the fires and floods were all the aftermath of a single visitor from the outer solar system, a giant comet that wandered too close and came apart. Imagine such a body long before it meets us. A loosely bound mass of ice and rock tens of kilometers across, orbiting in the deep freeze beyond Neptune. Slowly, over millions of years, gravitational nudges from the giant planets crank its orbit inward. It spends ages as a distant, unnoticed speck. Then, at last, it crosses a line where its path and Earth's begin to intersect. By the time it enters the inner solar system, sunlight is searing its surface. Frozen volatiles sublimate into vapor jets, spinning it, cracking it. The comet begins to shed fragments. First dust, then boulders. Then, as internal stresses build, whole chunks the size of city blocks. What was once a single nucleus becomes a drifting cluster of debris spread along its orbit. A cosmic shotgun blast instead of a single bullet. The Younger Dryas impact hypothesis proposes that around 12,800 years ago, Earth plowed through one of these dense swarms. In this reconstruction, the first sign would not have been a single bright point, but a storm of them. Multiple fireballs streaking across the sky over hours or days. Many would have disintegrated harmlessly in the upper atmosphere. But others, larger and more coherent, would have penetrated deeper, detonating at low altitudes as titanic airbursts. Some of those explosions, the hypothesis suggests, occurred over the Great Laurentide ice sheet that then smothered much of North America. Picture a detonation releasing as much energy as thousands of Hiroshima bombs, but focused downward onto ice. The upper layers flash melt, vaporize, blast outward in boiling plumes. Meltwater floods into glacial lakes and, from there, into the ocean. Other fragments explode over land, igniting forests and grasslands in hemispheric firestorms. It is a chaotic, almost unimaginably violent sequence. A far cry from a single neat crater. Supporters of the hypothesis argue that the geological and geochemical fingerprints match such a scenario better than any alternative. We have already seen some of the clues in the black mat. Glassy spherules formed when rock and soil are melted and flung into the air, then cool as tiny droplets. Nanodiamonds forged in high-pressure shock waves. Elevated levels of platinum and iridium, elements enriched in extraterrestrial material. Elsewhere, they point to patches of what looks like melted, splashed rock, high-temperature melt products that seem too extreme and widespread for simple wildfires or volcanism. In parts of the American Midwest, they highlight Carolina bays, thousands of shallow, elliptical depressions, as possible secondary blast features, though most geologists attribute them to long-term wind and water erosion. The pattern, proponents say, is global but patchy, just what you'd expect from a fragmented comet swarm. Hot spots of devastation separated by regions that escaped with less damage, within the same narrow time window. And yet, the case is far from closed. Many paleoclimatologists and geologists remain skeptical. They argue that the black mat's features can be explained by intense wildfires and wetland formation as ecosystems reorganized under a changing climate. They question whether the supposed impact markers are truly unique to cosmic events, or might also be produced by terrestrial processes. They note that no unambiguous, large crater dating precisely to 12,800 years ago has been found, though comet airbursts may not leave one. In some studies, attempts to replicate findings of nanodiamonds or elevated iridium have failed or produced more ambiguous results. Critics warn of selection bias, of researchers eager to fit scattered anomalies into a dramatic narrative. For every paper claiming support for the impact hypothesis, there is another disputing its methods or interpretations. What we are watching here is science in its raw, argumentative form. There is no tidy consensus yet, only competing models fighting over the same scraps of evidence, each refined by criticism. One side emphasizes internal dynamics. Meltwater pulses from decaying ice sheets disrupting ocean circulation with no need for a cosmic trigger. The other insists that the sheer abruptness and multi-continental synchronicity point to an external shock. Stepping back, it's worth remembering that even a partial version of the impact scenario would be enough to change everything. A single large airburst over an ice sheet could dump catastrophic meltwater into the North Atlantic, nudging the climate into instability. A regional rain of fire could wipe out key species, opening the door to extinctions and cultural collapses. We do not need a planet-killer asteroid to reset human history. A shattered comet misaligned by a few degrees might suffice. What makes the Younger Dryas impact hypothesis so haunting is not just its drama, but its timing. If it happened, it did so at a hinge point. When humans had spread across the world, experimented with complex hunting cultures, and begun tentatively to manage plants and animals. A swarm from the dark could have slammed that experiment back, forcing survivors to adapt in ways that ultimately prepared the ground for agriculture, cities, and myth. Whether the culprit was purely terrestrial or fell from the sky, the effect was the same. A planetary whiplash that our ancestors endured, recorded in other languages. Ash, ice, story. And if the trigger did come from a shattered comet, then the path that led to Sumer, to Uruk, to us, may have hinged on a broken piece of ice from beyond Neptune, arriving on schedule to redraw the script. If something from the dark did strike us at the dawn of the Younger Dryas, its mark is written not only in ice and ash, but in a sudden silence of footsteps. Before that line in time, Earth is loud with giants. Across the mammoth steppe of Eurasia and North America, herds of woolly mammoths and mastodons move like weather fronts, reshaping the land as they graze. Their tusks carve paths through snowdrifts. Their feet pound trails into permafrost. Their dung feeds beetles and fungi that, in turn, feed birds and small mammals. In the lakes and rivers of what is now Canada, beavers the size of black bears build massive lodges and dams. In the forests and open woodlands, giant ground sloths, towering as high as a small house, rear up to pull down branches, stripping leaves with massive claws that look more like weapons than tools. Predators follow this abundance. Saber-toothed cats slip through the long grass, two curved daggers gleaming whenever they yawn. American lions, larger than any modern big cat, patrol the edges of herds. Packs of dire wolves, heavier and more powerfully built than today's wolves, test the flanks of migrating animals, searching for weakness. In Australia, marsupial lions haunt the shadows. In South America, armored glyptodonts as big as cars trundle across plains, indifferent to all but the hungriest attackers. Humans live inside this world, not above it. For tens of thousands of years, our ancestors on every continent except Antarctica share their landscapes with megafauna. Animals weighing over 44 kilograms, many of them massively larger. For a hunter on the Pleistocene steppe, this is both danger and opportunity. A single mammoth can feed a band for weeks, provide hides for clothing and shelter, bones for tools and fuel. Their migration routes dictate where people camp, which valleys matter, which passes are worth remembering in song. And then, in what amounts to an instant on geological timescales, the giants are gone. Between about 50,000 and 10,000 years ago, but most intensely around the Younger Dryas boundary, a wave of extinction rolls across the continents. In Eurasia and the Americas, mammoths and mastodons vanish. So do the giant sloths, the saber-toothed cats, the American lions and cheetahs, the dire wolves, the giant beavers, the camels and horses that once roamed North America. In Australia, an earlier pulse had already removed most of the continent's megafauna shortly after humans arrived. Africa and parts of southern Asia fare better, but even there, the largest animals retreat or dwindle. In the ground, the change is abrupt. Below certain layers, a riot of bones. Above them, a quieter, more modest bestiary that looks increasingly like the modern fauna. The last dated mammoths on the continental mainland are barely older than some of the earliest known human settlements. On Wrangel Island and St. Paul Island, isolated remnant mammoth populations persist a little longer, ghostly holdouts in a diminishing world. Why did they disappear? For decades, two main culprits have wrestled for blame: climate and humans. As the Ice Age ended, habitats shifted rapidly. Grasslands became forests, wetlands dried or moved, ice sheets retreated. Then, in the Younger Dryas, partly returned. Large animals with slow reproduction and specialized diets are vulnerable to such upheavals. Climate-only models can recreate some of the broad patterns of megafaunal decline, especially in higher latitudes. At the same time, Homo sapiens was spreading into new continents with new technologies. The Clovis people of North America, with their elegant fluted spear points, are often depicted as big game hunters par excellence. Kill sites show mammoth bones scarred by butchery, surrounded by tools. In Australia, the coincidence between human arrival and megafaunal extinction is striking. The overkill hypothesis argues that even moderate increases in hunting pressure can drive slow-breeding giants to extinction over a few centuries. Layer the impact hypothesis on top of this, and the picture becomes more complex and more tragic. Cosmic airbursts and resulting wildfires could have instantly reduced available habitat, killed vast numbers of animals outright, and stressed ecosystems already wobbling from climatic shifts. Freshwater systems fouled by ash and silt, vegetation burned or flash frozen, migratory patterns disrupted. Into this chaos poured bands of hungry, adaptable humans with increasingly sophisticated tools. In that convergence, rapid climate change, human predation, and possibly a cosmic insult, lies one of the sharpest losses Earth has seen since the dinosaurs fell. For the people whose lives depend on these animals, the extinction pulse is not an academic puzzle. It is a lived catastrophe. A band that once planned its year around mammoth migrations now finds only empty valleys and scattered carcasses. Spears that were designed for huge, thick-skinned targets are suddenly overkill for deer and antelope. Knowledge passed down for generations. Where to intercept a herd, how to read the churned snow of 1,000 hooves, loses its value almost overnight. In the absence of giants, landscapes change again. Without heavy grazers, some grasslands thicken into scrub, altering fire regimes and water flow. Without large predators, prey populations boom and bust in more chaotic cycles. Humans, suddenly, are the only large, wide-ranging predators left in many ecosystems. We find ourselves at the top of an ecological pyramid that evolved without us in mind, surrounded by niches that have just gone vacant. This vacuum is both threat and invitation. On the one hand, it forces innovation. Some groups double down on smaller game and plant foods, experimenting with new hunting techniques. More intensive gathering, perhaps the first deliberate tending of wild grain stands. Others move, seeking refuges where remnants of the old megafauna still survive, only to find those refuges shrinking year by year. On the other hand, it invites story. In the generations after the last mammoth falls, children grow up hearing about animals they will never see. They inherit tales of a time when the world was bigger, stranger, more dangerous, and more generous. In those tales, the giants may become monsters, or gods, or both. Their disappearance begs for an explanation equal in scale to their presence. Did the gods grow angry? Did someone break a taboo? Did a celestial beast trample them into the sea? In a very real sense, the day the giants vanished is the day we became alone with ourselves. The ecological pressure and existential loneliness of that moment will, over thousands of years, help drive us toward new ways of living, new forms of power, and new myths to explain how a world so full of titans could empty so quickly and leave us holding the crown. Across the mammoth steppe of what is now North America, the end of the Pleistocene is written in more than bones. It is etched into stone, thin, deadly, beautiful. Scattered from New Mexico to Nova Scotia, buried in old river terraces and ancient campsites, archaeologists find the signature of a culture we call Clovis. Their calling card is unmistakable. A lanceolate spear point, broad-shouldered and elegantly tapered, with a distinctive channel flake removed from each face. This flute thins the base so the point can be hafted securely onto a wooden shaft. The workmanship is exquisite. Flakes have been struck off in careful sequence, leaving a symmetry that would impress a modern knife maker. In the hands of a skilled hunter, a Clovis spear is not just a tool. It is a key to a world. Picture one of those hunters on a cold morning, perhaps 13,000 years ago, somewhere along the margins of a glacial outwash plain. He stands with a small group at the edge of a low rise, scanning a valley where a herd of mammoths grazes among sedges and dwarf willows. Each spear in his hand or strapped to his back bears a point that may have taken hours to make. From carefully chosen chert or obsidian, carried long distances or traded from other bands. Around him, his culture is more than hunting. In nearby camps, others tend fires, process hides, nap new tools. Children learn to read tracks, to know the difference between the drag of a mammoth's foot and the lighter imprint of a caribou. Stories circulate at night about past hunts and ancestors' skill. The Clovis people are mobile, yes, but not primitive in the way we once imagined. They understand the patterns of rivers and seasons, the behavior of different prey, the qualities of different stones. Their presence is stamped across the continent in hundreds of sites. Then, in the stratigraphy of those sites, the line we have already met appears. Below a certain horizon, Clovis points are common. Above it, they are gone. It is not that humans vanish from North America. Other tool traditions appear in the levels immediately above, what archaeologists call Folsom, Gainey, Cumberland, and many others. These later points are often smaller, optimized for different prey. Settlement patterns shift. In some regions, there are signs of people focusing more on bison, deer, rabbits, and fish, less on massive, dangerous giants. But the Clovis culture, the specific combination of technology, hunting strategy, and social organization that produced those iconic fluted points, stops being visible as if a sentence had been cut off mid-word. What happened to them? One answer is already on the ground. their world changed. The Younger Dryas slammed cold into a warming continent, altered rainfall patterns, and changed vegetation. The mammoths and mastodons they specialized in were dwindling, then gone. Rivers they had known as clear, braided channels may have become clogged with silt from flooding as glacial lakes overtopped and burst. Carved pathways through forests might have burned or been buried under blowdowns. The landscapes encoded in their collective memory were overwritten in a few centuries. In that context, the disappearance of Clovis may represent not extinction, but transformation. Bands descended from Clovis' ancestors would have adopted new tools, targeted new prey. Technological traditions can shift rapidly when the prey they are optimized for vanishes. From the archaeological perspective, though, that shift looks like a break. The Clovis culture disappears because its diagnostic artifact, the fluted point, is no longer made or needed. Another, harsher possibility is that many groups simply did not survive the squeeze. Caught between fading megafauna, climatic chaos, and perhaps direct disaster, firestorms, floods from glacial dam failures, poisoned water, they may have dwindled past recovery. Their genes could persist in later populations, but their stories, their specific ways of doing and being, vanished with the last elders who remembered them. The timing of the Clovis decline, so close to the onset of the Younger Dryas and the Black Mat's line, is part of what makes this culture such a powerful microcosm of our larger mystery. Here we have a people who, by all evidence, had mastered their environment. Large-scale hunting of dangerous prey using sophisticated weaponry, wide-ranging knowledge of stone sources, flexible mobility. And yet, their distinctive presence on the record is abruptly extinguished. Clovis shows us that you do not need cities or writing to have something worth calling a civilization. You need shared knowledge, specialized skills, a way of relating to the land that is more than mere reaction. It also shows how little can remain of such a world after catastrophe. A few campsites, some butchered bones, a scatter of stone blades, suddenly replaced by others of a different style. No names, no myths, no remembered heroes. Unless somewhere, a story like theirs survived in the oral traditions of later peoples, unrecognizable to us now under layers of retelling. Standing in a lab, holding a Clovis point between gloved fingers, a modern archaeologist is touching the tip of a broken spear in more than one sense. It is the last preserved inch of a much longer shaft of culture, most of which has rotted away. If this is what survival in the record looks like for a continent-spanning hunting tradition only 13,000 years old, it forces a disquieting question. How many other Clovis-level societies, complex, adaptive, fully human, rose and fell in earlier millennia, in places now drowned by rising seas or buried under meters of sediment, leaving even fainter traces? How many times has the story of humanity been interrupted mid-sentence, with only a few elegant stones left to hint at the paragraphs we've lost? If the vanishing of Clovis and the giants is one side of the story, the other is written in what fell from the sky and what rose to replace it. Smoke. Charcoal is a stubborn survivor. Long after wood has burned and flesh has rotted, the blackened crumbs of ancient fires remain in soils and sediments, tiny witnesses to past flames. When scientists sieve mud from old lake bottoms and peat from bogs, they find these fragments embedded in layers corresponding to specific years and centuries. Plot their abundance through time, and you get a rough record of how much of the world was burning. Across the boundary of the Younger Dryas onset, that record spikes. In lake cores from North America, Europe, and parts of the Middle East, the concentration of charcoal suddenly surges. not just in one basin or one region, but across broad swaths of the northern hemisphere. In some sequences, the layers corresponding to around 12,800 years ago are so rich in burnt material that they stand out as dark bands, even to the naked eye. It is as if many landscapes on many continents caught fire at roughly the same time. In Greenland's ice, another set of clues appears. Mixed with the dust and volcanic ash are tiny black specks, soot, wafted high into the atmosphere by huge convection columns from wildfires below. Their frequency jumps at the same depth in the cores where the temperature curve drops and the Younger Dryas begins. Chemical signatures, such as elevated levels of ammonium and nitrate, support the idea of massive biomass burning. In Antarctica, at the other end of the world, some ice layers show subtler, delayed traces, as if smoke from faraway infernos eventually made its way even there, to reconstruct what that might have looked like on the ground. Researchers turn to models of mega-wildfires and to modern analogues. The Australian bushfires of 2019 to 2020, the Siberian and Canadian boreal forest fires, the catastrophic inferno that ripped through the Amazon in bad years. Scale those up, both in area and intensity, and extend them across continents. Imagine the American Great Plains, thick with dry grasses and dotted with stands of conifers, struck by a rain of molten glass and hot debris from overhead airbursts. Ignition points blossom into lines of fire whipped by wind. Separate blazes merge into walls of flame hundreds of kilometers long. Firestorms form, towering columns of superheated air that generate their own inward-sucking winds, drawing in more oxygen, feeding themselves until they punch smoke and ash into the upper atmosphere. In Europe, where the nascent forests have crept north into lands once held by ice, the story is similar. Pine and birch burn hot and fast. Peatlands, ancient accumulations of semi-decayed plant matter, smolder underground, releasing fumes for months. Lightning storms triggered by the fire columns spark new blazes ahead of the main fronts. Animals flee until they cannot, then fall. Some landscapes burn so thoroughly that the very soil chars. For the people scattered across these continents, fires are nothing new. Controlled burns and lightning-triggered wildfires are part of the rhythm of many ecosystems, and humans had long learned to use and respect them. But this is different in both scale and persistence. Instead of discrete blazes with clear edges and endings, they face seasons where the horizon is permanently smeared in brown and orange, where the smell of smoke never quite leaves the air. During the days, the sun becomes a dimmed coin, its light filtered through a high haze of soot and aerosols. Shadows blur. Temperatures at the surface may drop in the short term as sunlight is scattered back to space, even as the globe's energy balance is violently perturbed. Plants struggle. Reduced light means reduced photosynthesis. Growth slows or stops. In already stressed ecosystems, those recovering from glacial retreat or abrupt cooling, the extra blow can be fatal. At night, the sky is wrong. Stars that once glittered in sharp patterns are veiled, seen only as faint glows through a diffuse brown canopy. Sometimes the copper disk of the moon rises blood red through layers of smoke. Other times, flashes on the horizon, distant crown fires racing over ridges, outshine the constellations. Migratory birds, guided by starlight, become lost. Insects die in vast numbers as their host plants wither. Food chains, finely tuned to particular temperatures and growing seasons, wobble and in many places collapse. Those who survive this period of fire and darkened suns do not experience it as a chart or model. They live it as a series of violated expectations and accumulating dread. The sun, which has always risen bright and traced a predictable arc, now appears sick, distant, obscured for days or weeks at a time. The stars, which have always told reliable stories about direction and season, seem to fall. Meteors streaking more often than before, or perhaps simply more noticed in the fearful eyes of those who have already seen too much from the sky. Is it any wonder that thousands of years later, so many mythologies speak of days when the sun was blotted out, when stars fell like leaves, when the sky rained fire, when night lasted too long? Or that they tie such imagery to moral narratives of judgment and renewal, worlds destroyed because of human pride or divine anger, then remade. What we call soot and aerosols, radiative forcing and biomass burning, they would have understood as omens, punishments, portents. For a child born into such a time, the first clear, blue, smoke-free sky might feel like a miracle. For an elder, the memory of a normal sky might become sacred knowledge, something to be wrapped in ritual and retold with warnings attached. In this way, physical trauma hardens into psychological scar, and scar into story. Firestorms and darkened suns become the raw material of apocalyptic visions, not fantasies of future doom, but compressed, half-remembered reports from a past when the air itself seemed to turn against life. Long after the last embers die and the skies clear, something of that terror keeps moving, from breath to breath, from story to story. The soot settles, the glaciers retreat for good, shorelines redraw themselves. Children are born who never see a firestorm, never taste ash in the rain. But when they sit by the evening fire and ask where the world came from and why things are the way they are, the answers they receive carry faint echoes of those earlier nights when the sky went wrong and the seas did not stay where they belonged. Follow those echoes far enough, and you find yourself in the oldest written literature we possess. On clay tablets from Mesopotamia, pressed with wedge-shaped cuneiform signs, the Epic of Gilgamesh tells of Utnapishtim, the man who survived a flood that wiped out the world. The gods, annoyed by the noise and restlessness of humankind, decide to erase their creation with waters that rise over the tops of mountains. One sympathetic deity whispers a warning through a reed wall, instructing Utnapishtim to build a great boat, to seal it with pitch, to take aboard his family, artisans, and the seed of all living things. The storm comes. The deluge rages for days. When at last it ends, he sends out a dove, then a swallow, then a raven to see if the waters have receded. Only the raven fails to return. Centuries later, in a different culture with different gods, the Hebrew Bible records a story that is strikingly familiar. This time the cause is moral corruption. The protagonist is Noah. He too is warned by his deity. He too builds an ark. He too rides out a flood that covers all the high mountains under the whole heaven. He sends out a raven, then a dove, waiting until the bird returns with an olive leaf in its beak. As the waters retreat, the ark comes to rest upon the mountains of Ararat. In Greece, Plato has his character Chrysias recount the tale of Deucalion, who with his wife Pyrrha survives a flood sent by Zeus to wipe out an arrogant Bronze Age humanity. Warned by his father Prometheus, Deucalion builds a chest, climbs into it, and floats for 9 days and nights before washing ashore on Mount Parnassus. From there, he and Pyrrha repopulate the world, sometimes by throwing stones over their shoulders that turn into people. In ancient India, the Satapatha, Brahmana, and later the Puranas tell of Manu, a righteous man warned by a fish that a great flood is coming. He builds a boat, ties it to the horn of the now enormous fish, an incarnation of the god Vishnu, and is towed to safety above the drowning earth. When the waters recede, Manu performs a sacrifice, and from that act, a new humanity arises. China has many flood stories, but one of the oldest and most influential is that of Yu the Great, who does not build an ark, but instead labors for years to tame a deluge that has covered the land, cutting channels and dredging rivers until order is restored. The waters themselves are less a punishment than a chaos that must be managed. Yet the scale is still cosmic. Mountains are moved, the very courses of rivers reset. Cross the oceans to the Americas, and you encounter variations on the same theme among indigenous nations separated by thousands of kilometers. In some traditions of the Pacific Northwest, a great flood rises until only those who lash their canoes to the tops of tall mountains or trees survive. Among the Maya and other Mesoamerican peoples, earlier worlds end in water before the current age begins. In Andean myth, the god Viracocha sends a flood to wipe out a race of giants, sparing only a few in a cave or on a mountaintop to start anew. Sail across the Pacific itself, and island after island in Polynesia, Micronesia, and Melanesia has its own account of waters that rose above the coconut palms, of people saved on rafts, in canoes, or on sacred peaks, of birds sent out to find land, of rainbow messengers when the danger passes. In Australia, some Aboriginal oral traditions describe shorelines where none now exist, rivers where none now flow, and floods that swallowed ancestral lands. Details that, astonishingly, sometimes match reconstructions of sea level rise after the last ice age. Taken individually, any one of these stories could be dismissed as allegory or coincidence. People everywhere know local floods. It is natural that they would project those experiences onto their cosmologies. Taken together, though, patterns emerge that are hard to ignore. A world destroyed not by ordinary bad weather, but by waters that overtop the highest familiar points. A select few warned in advance, told to prepare some kind of refuge. An emphasis on preserving life, not only humans, but animals, seeds, knowledge, birds as scouts, mountains as the first dry land to reappear. A covenant or new order established afterward, whether in the form of a divine promise, a changed relationship to the gods, or a new social contract. From the perspective of geology, there is no single global flood that matches these tales in exact detail. Sea levels rose over thousands of years, not 40 days. Local megafloods from bursting glacial dams scoured some valleys in hours, but left others untouched. Tsunamis triggered by submarine landslides or impacts ravaged particular coasts, not entire planets at once. Yet oral traditions do not keep time with calendars and isotopes. They compress, conflate, and translate. A series of catastrophic regional floods spaced over generations can, in memory, fuse into one archetypal deluge. The flood, the line between a before world and an afterworld. The specifics of which river overflowed, which ice dam broke, which bay drowned, may be lost. What remains is the emotional truth. The sky darkened, the waters rose higher than anyone had seen. Almost everyone died. We were saved by an act of foresight or favor, and the world that followed was not the same. Anthropologists have begun to test the endurance of such narratives. In some parts of Australia, oral stories about the drowning of coastal plains appear to encode accurate descriptions of sea level rise events that occurred 7,000 to 10,000 years ago. Hundreds of generations in the past, around the Mediterranean, memories of islands splitting or being swallowed may trace back to real Bronze Age earthquakes and tsunamis. Human communities, especially those with strong storytelling traditions, can carry fragments of environmental history in mythic form far longer than we once believed possible. Seen this way, global flood myths are not proofs of a single event, but data points in a vast, messy archive of human experience. They are the subjective counterpart to the objective records in ice and stone. Where the ice core shows a spike in meltwater, the myth shows a god's anger. Where the sediment records a tsunami deposit, the story remembers a wave that climbed the cliff no one thought it could reach. Somewhere in the overlap, where charcoal layers, sea level curves, and tales of drowned worlds all cluster, we may be glimpsing how our ancestors tried to make sense of living through environmental shocks on a scale their languages barely contained. For them, to say the world ended in water was not hyperbole. It was a way of saying everything we knew drowned, and we had to start again on whatever high ground we could find. Those stories of drowning worlds and second chances feel mythic. But written into every one of us is another kind of record. One that doesn't care about gods or arcs, only about who lived long enough to have children and who did not. If charcoal and clay tablets are the planet's external memory, DNA is our internal one. When geneticists first began sequencing human genomes from around the world and comparing them, they weren't looking for cataclysms. They were looking for patterns of relatedness, for clues to where and when our species arose. What they found instead was that our family tree has some very narrow branches. Reconstructing past population sizes from modern genomes is a bit like reverse engineering an ancient forest from the growth rings of its surviving trees. Mutations accumulate over generations, and the diversity and distribution of those mutations tell you how many lineages were present and how often they interbred. Run those models backward for Homo sapiens, and you do not see a steady, unbroken climb. You see bottlenecks, periods when the effective number of breeding humans shrinks dramatically. One of the deepest of these seems to lie far back, perhaps 60 to 70,000 years ago, possibly associated with our species spread out of Africa and the super eruption of Mount Toba in Indonesia. Another, more subtle set of constrictions appears later, within the very window we've been exploring. The last 30,000 years, when ice sheets advanced and retreated, giants vanished, fires darkened the skies, and floods remade shorelines. What does a bottleneck mean in human terms? It means that, for a time, the entire global population may have been reduced to tens of thousands, or in some estimates, even fewer. Imagine the world's 7+ billion people abruptly compressed into the population of a small modern city. Now imagine that those survivors are not in one place, but scattered in thin bands across continents. Family groups, small tribes, refuges clinging to river valleys and coasts that still work. In that scenario, many entire cultures can, and likely did, disappear. A language spoken by a few hundred people in a vulnerable valley might vanish in a single bad winter. A ritual that depends on a particular animal might be abandoned when that animal goes extinct. A style of tool-making, a way of reading the stars, a story about how the world began. If they are not carried by those who pass through the bottleneck, they are erased. Yet not everything is lost. Even as cultures die, genes move. Groups merge, split, intermarry. Children of one tradition are raised in another. Over tens of thousands of years, this movement leaves subtle statistical fingerprints in our genomes that modern methods can tease out. When researchers do this at large scales, comparing hundreds or thousands of genomes from different regions, they sometimes find evidence for ghost populations. Ancestral groups that must have existed and mixed with the ancestors of living people, but that do not correspond neatly to any known archaeological culture. In Europe, for example, the genomes of early farmers, hunter-gatherers, and later Bronze Age pastoralists all bear traces of additional, unsampled lineages. In Africa, where our species' roots are deepest and most tangled, Genetic data reveal ancient splits and mergers among populations that left no clear physical record at all. Even Neanderthals and Denisovans, our extinct cousins, survive as a few % of DNA in many of us, long after their bones turn to dust. These ghostly threads suggest that the story told by artifacts alone is radically incomplete. Between the caves and the cities, between the mammoths and the ziggurats, there may have been whole constellations of societies, each with its own names for the stars, its own gods, its own technologies, that left very little we can dig up. Their existence is inferred not from potsherds, but from patterns of base pairs. Now place those genetic bottlenecks alongside the climatic and geological events we've traced. A 1,000-year cold snap like the Younger Dryas, coupled with continent-scale fires and floods, is more than enough to squeeze populations. Regions that were once prime habitat become lethal or barren. People cluster in refugia, ice-free pockets with reliable water and food. In those refugees, a few lineages expand while others vanish. When the climate flips back to warmth, the descendants of those few spread into the emptied spaces, carrying with them a narrower slice of the cultural and genetic diversity that once existed. This does not mean there was a single, unified, lost civilization whose memory we preserve. It points instead to something messier and, in its own way, more haunting. A succession of worlds within our world, each made of many small, intricate cultures, many ways of being human, repeatedly thinned by environmental shocks. History, as we write it, is biased toward what leaves stones in the ground and ink on pages. But the deeper we look into genomes, the clearer it becomes that for every story we can reconstruct from ruins, there are many others whose only surviving trace is a statistical ghost in our blood, and perhaps a dim resonance in myths of floods, fires, and beginnings after endings. Realizing this changes how we see that 30,000-year gap. It is not an empty hallway between primitive hunters and real civilization. It is a cemetery of forgotten experiments in living, paved over by later successes. Our species has more graves than books. And if so much can vanish in such a short slice of deep time, we have to ask, what else might have risen and fallen, entirely beyond our current reach, in the long night before the first cities wrote their names in clay? Step back from the details, the nano-diamonds, the fluted points, the soot in ice, and look at the timeline as a whole. The Younger Dryas ends around 11,600 years ago. The first unmistakable cities in southern Mesopotamia, with ziggurats and written records, appear roughly by 5,000 Asans to 4,000 BCE. Between those two markers lies almost 10,000 years, longer than the span from the first Sumerian tablets to the smartphone in your pocket. On most historical charts, that whole interval is compressed into a thin, gray band labeled something like Neolithic or prehistory, as if nothing much happened until someone finally thought to stack mud bricks high enough to call it a temple. But from the planet's point of view, those were among the busiest millennia it has seen. As the Younger Dryas cold relents, temperatures climb sharply. Glaciers that had paused or re-advanced resume their retreat, this time for good. The great ice sheets of North America and Northern Europe begin to waste away in earnest, their meltwater pouring into rivers and oceans. The sea, which had been more than 100 meters lower at the height of the Ice Age, starts to rise. At first, the change is subtle. A shoreline might move a few meters inland in a human lifetime, hardly noticeable against the vagaries of tides and storms. But decade after decade, century after century, the encroachment continues. Low-lying areas flood permanently. River mouths drown, islands shrink, estuaries push farther inland. On maps reconstructed by geologists, Continental shelves that are now submerged appear as vast plains. A broad valley where the English Channel is, a land bridge connecting Siberia to Alaska, an enormous lowland joining the islands of Southeast Asia into a subcontinent. Doggerland, for example, once stretched between what is now Britain and mainland Europe. A rich, marshy, river-laced landscape where Mesolithic hunters stalked red deer and aurochs. Over a few thousand years after the Younger Dryas, that world dissolved. Rising seas turned hills into islands, then archipelagos, then sandbanks. Storm surges and perhaps tsunamis tore at its edges. By around 6,000 to 5,000 BCE, Doggerland was gone, its last high points reduced to shoals treacherous to passing ships. Similar fates befell many other coastal plains. The Persian Gulf Basin, now filled with seawater, was once a broad, fertile valley where the Tigris and Euphrates joined and flowed out to a much more distant shore. Parts of the Sunda Shelf between mainland Southeast Asia and Indonesia were dry land, threaded with rivers and mangroves. Around the Indian subcontinent, wide coastal lowlands now lie under tens of meters of water. For people living there at the time, the loss was not an abstract sea level curve. It was the gradual drowning of home. Villages moved, then moved again. Then elegies spoken for places that could no longer be reached, except in dreams. At the same time, new ecosystems were being born. As ice withdrew from Scandinavia and Canada, soils developed where there had been only rock and meltwater. Boreal forests advanced, then mixed woodlands, then in some regions open grasslands. Animals followed, and with them people, moving into freshly unveiled corridors. Cultures that had huddled in refugia during the cold, along ice-free coasts, in river valleys, in pockets of steppe, spread out to colonize the deglaciated lands. Others, displaced by the advancing sea, migrated inland or along new coasts, carrying seeds, tools, and stories. This was the era when agriculture emerged not in one place, but in several, independently. In the Levant and Upper Mesopotamia, people who had long gathered wild grains began to tend and domesticate them, gradually turning mobile foragers into settled farmers. In China's Yellow and Yangtze river basins, millet and rice cultivation took hold. In the New Guinea highlands, tuber agriculture emerged. In Mesoamerica, early forms of maize, squash, and beans were being shaped. In each case, what we see in the record is not a single leap, but centuries of experimentation. Selecting plants, managing landscapes with fire, building up soil. These shifts were cultural revolutions on a scale we still struggle to appreciate. They changed diets, social structures, disease patterns, gender roles, relationships to territory and time. They laid the foundations for villages, then towns, then the first dense, hierarchical societies. And yet, for much of this period, the most promising places to experiment with complex organization, broad river valleys, deltas, protected bays, were also the most vulnerable to the creeping sea. So we are forced to ask a question that sits at the edge of current knowledge. If early experiments in large-scale cooperation, proto-cities, dense trade hubs, permanent ceremonial centers, arose along those now submerged coasts, how much of that story have we simply lost under 100 meters of salt water? Underwater archaeology is in its infancy compared to terrestrial digs. A handful of sites, submerged stone structures off India's coasts, remnants of ancient shorelines with tools still in place, drowned forests, hint at the richness that might lurk on the seafloor. But mapping, let alone excavating, the vast tracts of former coastal plains is technologically difficult and expensive. It may be generations before we can say with any confidence what lies beneath. Meanwhile, our narrative retains a bias. We tell the story of civilization's birth from the vantage point of the survivors. Those inland river cultures in places like Sumer and Egypt, who rose to prominence after the seas stabilized, on land that stayed above water. Their records survive because their cities did. Earlier coastal centers, if they existed, would have had their clay tablets dissolved, their wood rotted, their mud bricks scattered. Only stone would persist, and even that tumbled and buried under silt. Between the end of the Ice Age and the rise of Sumer, then, the long silence is likely less quiet than it appears. It is filled with the sounds of waves climbing old shorelines, forests marching north, peoples mixing and moving, crops being coaxed from wild grasses, and perhaps, on coasts we can no longer walk, gatherings and structures complex enough that, had they been built inland, we would call them the first cities. If so, the gap in our history may be less about what never happened, and more about where it happened. In places now held by the sea, beyond the reach of most of our tools, the missing chapters may be out there still, silted over and silent, waiting for us to learn how to listen below the waves. To feel what we may have lost, redraw the map in your mind. Start at the peak of the last ice age, around 20,000 years ago. The world's waters are locked up in titanic glaciers. Sea level is more than 100 meters lower than today. The familiar outline of the continents bulges outward. Where the North Sea now lies, a broad, plain stretches between Britain and mainland Europe. The English Channel is not a strait, but a green valley, carrying the combined flow of Rhine, Thames, and Seine toward a distant Atlantic shore. Around Southeast Asia, the islands of Indonesia are fused into a single landmass, Sundaland, extending from present-day Indochina almost to Borneo and Java as one continuous peninsula. Between Arabia and Iran, the Persian Gulf does not exist. In its place is a deep, river-cut basin. Roll the clock forward to 15,000 years ago. The great ice sheets have begun to thin. Meltwater pulses into the oceans. Shorelines creep inward. Doggerland's western edge frays into marshes and lagoons. River mouths that once opened onto dry land begin to backfill with brackish water. Along what will become the North Sea, reindeer and human hunters traverse an increasingly soggy landscape. In Sundaland, low-lying coastal forests flood. Deltas reconfigure. Mangroves advance into what were once inland valleys. The ancestral Mekong, Chao Phraya, and other rivers pour across a vast, gently sloping shelf. At 10,000 years ago, the world is warmer still. Sea level has risen by tens of meters. Doggerland is now a patchwork of islands and tidal flats, still habitable but precarious. Storm surges and high tides claim more ground each year. In Southeast Asia, the encroaching ocean has carved gulfs where once there were plains. What will become the Java Sea, the Gulf of Thailand, the South China Sea are busy drowning former river networks. In the Persian Gulf Basin, the combined flow of the Tigris, Euphrates, and Karun cuts a great meandering channel down the center of a long valley, its sides slowly eaten away as the sea pushes in. From space, if you could have watched, these changes would look stately, almost slow. From the ground, they would feel different. A fishing camp that once sat comfortably above the tide line finds its hearthstones lapped by waves a few decades later. A grove of fruit trees, planted by grandparents, begins to die as salt creeps into the soil. Paths to traditional hunting grounds are cut by new inlets. Burial grounds are washed away in storms that strike a little farther inland each cycle. We know these worlds existed because the planet has left ghost images of them. Sonar studies of modern continental shelves reveal drowned river valleys etched into the seafloor. Meandering channels that once carved through air, now filled with sediment. Off the coast of Western Australia, researchers have found submerged freshwater springs, remnants of ancient aquifers. In the Black Sea, core samples show a shift from freshwater to marine mollusks as the Mediterranean breached the Bosporus and poured in. Around the British Isles, trawl nets occasionally bring up peat, antlers, even worked flint from banks that were once Doggerland's dry ground. On the Sunda Shelf, bathymetric maps show the branching pattern of ancient rivers converging into a central trunk, flowing southward, now hidden beneath the Java Sea. This drowned landscape would have offered diverse habitats: riverine corridors, broad floodplains, coastal lagoons, perfect for early human settlement. Yet whatever campsites, middens, or more permanent structures once existed, there are now under tens of meters of water and silt. The same is true of the Persian Gulf Basin. High-resolution seismic surveys have mapped buried channels and terraces, suggesting a long-inhabited valley, later transformed into a gulf as sea level rose. In some reconstructions, the head of that valley, where the Tigris and Euphrates met, would have been a particularly rich, well-watered region, a potential cradle for dense early communities. Archaeological hints are beginning to emerge. Off India's west coast near the Gulf of Comet, controversial discoveries of arranged stone blocks and artifacts at depth have sparked debates about possible prehistoric structures. In the eastern Mediterranean, sonar has revealed submerged stone walls and foundations near now inundated coasts. At Boldner Cliff, off Britain's Isle of Wight, divers have uncovered Mesolithic flint tools and wooden platforms preserved an astonishing 11,000 years under the Solent. These are small windows into a much larger, largely unseen archive. What would happen to a coastal settlement or even a small city as the sea rose around it over centuries? First, erosion would nibble at its edges, undermining walls, exposing foundations. Floods would deposit layers of sand and silt over its floors. If its people retreated inland, they might strip the site of reusable materials, leaving only stone and clay. Eventually, waves would overtop it entirely, reducing walls to tumbled rubble. Over millennia, currents would bury and scatter even that, grinding some stones down, covering others under meters of sediment. Organic materials, wood, textiles, leather, papyrus, would rot unless sealed in low-oxygen mud. Metal would corrode. Clay tablets, if unbaked, would dissolve. What might survive would not look to us like a city. It would look like a few anomalous blocks on a sonar map, an unnatural line among natural ripples. It might be mistaken for a reef, a rock outcrop, a quirk of deposition. Only with targeted investigation, the kind we have only begun to attempt, would its human origin become clear. Meanwhile, on land, the memory of the place could persist. In stories, it might become the land that sank, the garden beneath the waves, the valley the sea stole. Over generations, as storytellers compress time and add meaning, a 1,000-year sequence of gradual inundation might be remembered as a single generation's punishment or tragedy. Once, our ancestors were foolish or wicked, and the ocean rose to swallow their home. Only those who heeded the warning climbed to the mountain and survived. In this way, drowned coastlines and sunken plains do double duty in our investigation. Physically, they represent enormous missing canvases, prime real estate for early complexity now hidden underwater. Culturally, they may be the factual bedrock beneath myths of Atlantis, Kumari Kingdom, Aztlan, and other lost lands. When we speak of a 30,000-year history gap, part of what we're really naming is this drowned world, an entire band around the continents where countless human lives were lived, and whose stories now lie muffled under waves, hinted at only by the contours of the seafloor and the tales of paradises taken by the sea. Step inland from those drowned coasts into the dry hills of southeastern Turkey, and you find something that by all rights should not exist, where and when it does. The locals call the place Göbekli Tepe, the Potbelly Hill. For a long time, it seemed unremarkable, just another low rise dotted with stones and grazed by sheep. Then, in the 1990s, excavation began, and the hill started to tell a different story. Beneath a few meters of soil, archaeologists uncovered circles. Each circle is defined by massive T-shaped limestone pillars, some up to 5.5 meters tall, weighing 10 to 20 tons. They stand in carefully arranged rings, linked by low stone walls. At the center of many enclosures rise two larger T-pillars, facing one another like frozen figures in conversation. The T-shape is not just structural. Carved reliefs show that the crossbar represents arms folded across a chest, the shaft a long, stylized torso. These are not abstract megaliths. They are humanoid, monumental beings cut from the bedrock itself. The surfaces of the pillars are alive with imagery. Foxes, wild boar, aurochs, gazelles, vultures, snakes, scorpions, spiders, cranes. Creatures of the surrounding landscape rendered in crisp, low relief. Some animals are stacked in vertical registers, others arranged in bands around the stones. Here, a snarling predator clutches a prey animal. There, a vulture looms over a headless human figure. Some motifs repeat across different enclosures, suggesting shared themes or a symbolic grammar. Radiocarbon dates from associated charcoal and sediments place the earliest phases of Gobekli Tepe at around 9,600 BCE, roughly 11,600 years ago. That is the same moment the Younger Dryas ends, the same moment when ice cores show the world snapping from cold back into warmth. It is more than 6,000 years older than Stonehenge, 7,000 years older than the first pyramids, older than pottery in most places, older even than domesticated cereals in the nearby Fertile Crescent. According to the standard narrative, the sequence is supposed to go like this: first agriculture, then surplus, then settled villages, then specialization and hierarchy, then, finally, monumental architecture and organized religion. Gobekli Tepe inverts that order. Here, hunter-gatherers, or at best, very early horticulturalists, are hauling multi-ton stones up a hill, carving them with sophisticated art, and arranging them in carefully planned circles. Who were these people, and why did they do this? One mainstream interpretation sees Gobekli Tepe as a ritual center built and maintained by multiple mobile groups. Bands of foragers from the surrounding region may have gathered at certain times of year, perhaps keyed to celestial events or animal migrations, to conduct ceremonies, feasts, and social negotiations. The site's scale and labor demands would then have been a catalyst for more organized cooperation, perhaps even nudging people toward more intensive food production to support these periodic building projects. In this view, religion and monumentality come first. Agriculture follows to keep the temples fed. Another line of thought takes Gobekli Tepe's timing and iconography and connects them more explicitly to the cataclysms we've been tracing. Some researchers have argued that certain animal arrangements on a pillar known as the vulture stone might encode a constellation pattern, a kind of prehistoric star map marking a specific date, potentially corresponding to the onset of the Younger Dryas and a notable meteor shower. Others caution that we are reading too much into ambiguous symbols. But the possibility hangs there. Could at least part of the imagery be a deliberate attempt to freeze in stone a memory of something seen in the sky and on the earth? Even without that specific claim, the site feels like a memory palace, a place where knowledge, fears, and hopes are anchored to enduring forms. The T-pillars, with their abstracted human features, might represent ancestors, gods, or culture heroes. The surrounding animals could encode stories about creation, destruction, and the proper relationship between humans and the wild beings on which they depended. In a world only recently emerged from a millennium of climatic chaos, the act of building a stable, enduring stone circle on a hill may have been a way of asserting order against the caprices of ice and fire. Then, there is the most puzzling fact of all. Gobekli Tepe was deliberately buried. Over centuries, perhaps more than 1,000 years, its builders filled in the enclosures with rubble, broken stone, and refuse, entombing the pillars they had raised. New, smaller enclosures were built on top of older ones in a kind of telescoping sequence, each generation partially covering the work of its predecessors. By the time the site was finally abandoned, it was no longer a forest of open rings, but a layered mound, a hill with a stone heart. Why pour so much effort into creating something so grand, only to bury it? Was it a ritual decommissioning? A way of respectfully retiring a sacred place when its function was complete? Was it protection, an attempt to hide and preserve the stones against some perceived threat? Or simply the byproduct of long use, with each phase filling the last as needs and beliefs shifted? Whatever the answer, Gobekli Tepe stands in our story as a stark, physical whisper from just beyond the edge of the Ice Age. It says, "At the very moment the climate snapped from Younger Dryas cold into our current warm epoch, there were people here who could organize large labor forces, plan and execute complex architectural projects, and carve symbolic art of startling power. They were, by every conventional label, hunter-gatherers. Yet they carried ideas and skills that would not look entirely out of place in the temple districts of much later Sumer. Someone, it seems, carried more than just fire and stone tools through the darkness. They carried concepts of sacred space, of encoded knowledge, perhaps even of time and stars, that survive in this hilltop sanctuary. Gobekli Tepe may not be a lone anomaly. It may be the first clearly visible tip of a much older, partially submerged iceberg of complexity, rising from the same deep waters that drowned so much of our early story. From Gobekli Tepe's hilltop, it is only a small step in imagination to the idea that stone itself can think, not in the way a brain does, but as a medium for memory. Our ancestors did not have silicon, paper, or hard drives. What they did have were skies that never turned off, and rocks that, once moved with enough effort, tended to stay where they were put. Put those two together, and a pattern emerges. Around the world, at different times, people drag heavy stones into carefully chosen lines that talk to the heavens. Consider a more familiar example: Stonehenge. Today, tourists walk its ring of trilithons on the Salisbury Plain, often on gray, drizzling days. But its builders, millennia after Gobekli Tepe, arranged those upright stones and lintels with astonishing precision. Stand at the center on the morning of the summer solstice, and the sun rises directly over the heel stone, framed in one of the main sight lines. At the winter solstice, sunlight pours in along the opposite axis. The monument is not just a circle, it is a machine for marking the turning points of the year. Stonehenge is far from unique in this. The passage tomb of Newgrange in Ireland, built around 3200 BCE, has a long, narrow corridor leading into an inner chamber. For most of the year, that inner space is pitch black. But at dawn on the winter solstice, a shaft of sunlight slips through a specially designed roof box above the entrance, travels down the passage, and illuminates the central chamber for a few brief minutes. Someone designed that effect, tested it, refined it, a collaboration between stone and sky. Travel to the Americas and you find similar conversations. At Chaco Canyon, in what is now New Mexico, the ancestral Puebloans built great houses with windows and wall segments aligned to solstice and equinox sunrises and sunsets. On Fajada Butte, a spiral petroglyph is sliced by beams of light at key solar events. A subtle interplay of rock, shadow, and celestial motion. In Mesoamerica, Maya observatories like El Caracol at Chichen Itza have windows oriented toward the extreme rising and setting points of Venus, a planet they tracked obsessively. Then there are alignments keyed not just to the sun's yearly dance, but to much slower cycles. The moon, for example, wobbles in its orbit over an 18.6-year period known as the lunar standstill cycle. At maximum standstill, it rises and sets at its most extreme northern and southern points on the horizon. Certain Scottish and Irish megalithic sites, such as the complex at Callanish on Lewis, are oriented in ways that appear to mark these rare lunar extremes. To detect and encode such a pattern, observers would have needed to watch the sky carefully over decades, long enough to see the moon's behavior shift and return. And beyond even that lies precession. The slow 20-year wobble of Earth's axis that causes the positions of the equinoxes and solstices against the backdrop of stars to drift. Detecting precession requires comparing star positions across many generations. Some researchers have argued that certain ancient zodiacs, architectural orientations, or even mythic ages hint at such awareness, though the evidence is debated. Still, the possibility is provocative. Did some early sky watchers notice that the fixed stars were not entirely fixed? All of this raises a fundamental question. Why go to such trouble? The practical uses of astronomy are real and important. Knowing when the solstices and equinoxes fall helps time planting, harvesting, migrations, and ritual cycles. In a pre-industrial world, the sky is the only truly global calendar. But in the context of repeated environmental shocks, of sudden winters, strange summers, floods, and fires, it may also have taken on a more urgent, anxious role. If your grandparents told you that once, without warning, the seasons broke, that winter came too soon or stayed too long, that the sun was dimmed, that the stars moved strangely, you might begin to watch the sky not just with curiosity, but with fear. You might look for patterns that repeat before such disasters. A particular brightness of a star, an unusual path of a comet, a certain clustering of planets. Over time, your culture might come to believe that by tracking these signs, you could foresee, or even avert, the next calamity. Stone becomes the medium in which you store your conclusions. Unlike oral memory, which dies with individuals, a stone alignment endures. A future generation, even if it has forgotten the original reasoning, can still see that on a certain day the sun rises exactly between two pillars, or that the full moon at its farthest northern rise skims along a certain notch in the hills. Rituals accrete around these moments, festivals, offerings, stories about why this dawn or that moon matters. In this way, practical sky knowledge is wrapped in religion, preserved because it is sacred. Viewed through this lens, megaliths are not just temples to gods we no longer recognize. They are data storage devices, three-dimensional, experiential hard drives encoding cycles of time. Their orientations and sightlines tell the sky story in geometry. Their carvings, a row of animals, a pattern of dots, a spiral, may compress observations or myths linked to particular celestial events. When a culture has no writing system, or only a nascent one, stone and story work together to fix knowledge against the erosions of forgetting. Now connect this back to the trauma of cosmic and climatic upheavals. If the Younger Dryas and its fires and floods were triggered, at least in part, by an encounter with a debris stream, a cluster of comet fragments crossing Earth's orbit, then knowing when you pass through such hazard zones becomes literally existential. Even if the correlation is imperfect, even if most years nothing happens, the incentive to find any kind of pattern in the heavens is immense. In that context, the great stone circles and alignments of the early Holocene can be seen as the nervous system of a species trying to monitor the pulse of the cosmos. What we interpret as pure religious fervor may, in part, be a desperate attempt to build a reliable cosmic clock, to mark the beats of the sun, the moon, and the stars so carefully that any future deviation, any whisper of impending skyfall might be caught in time. Whether or not they succeeded, those stone libraries are still there, their files mostly unread by us. We walk among them as tourists, marveling at their age, posing for photos at solstice sunrises, rarely stopping to consider that behind their beauty lies an old fear, that the heavens are not always benign, and that to survive here long term, you must learn to listen to their cycles as if your life depends on it. Because once, it probably did. Follow those stone libraries forward in time and space, and their alignments begin to converge on a particular patch of Earth. The floodplains between the Tigris and Euphrates. Here, in what is now southern Iraq, something happens around 6,000 years ago that has so dominated our imagination, we often treat it as the true beginning of history. Mud brick cities rise. Temples stack upward into the first ziggurats. Clay tablets fill with wedge-shaped signs. We call this moment the birth of civilization, and we give it a name, Sumer. But what if Sumer is less a birth than a rebirth? On the surface, the story looks like an explosive innovation. In the city of Uruk, around 3,300 to 3,200 BCE, administrative marks on clay tokens and bullae evolve into the earliest known writing. At first, the signs are pictographic, tallying barley, beer, cattle. Soon they become more abstract, capable of recording not just goods, but names, transactions, even snippets of myth. Around the same time, Sumerian scribes settle on a sexagesimal, base 60 system of mathematics, dividing circles into 360 degrees, hours into 60 minutes, minutes into 60 seconds. They standardize measures of length, weight, and capacity. They draft legal contracts, hymnals, king lists. This cluster of innovations feels abrupt until you set it against the long, shadowed ramp behind it. Millennia of sky watching, flood memory, stone-encoded calendars, drowned coasts, and experimental settlements. Then Sumer looks less like a spark from flint and more like a flame taking hold in a pile of very dry, very old tinder. The Sumerian king list is a particularly curious ember. Inscribed on tablets and prisms, it purports to record a continuous line of kings stretching from the distant past to the scribe's present. At its beginning, we read a strange phrase. After the kingship descended from heaven, the kingship was in Eridu. What follows are antediluvian rulers whose reigns stretch into the tens of thousands of years. 8 kings rule for 200 years before the flood swept over. And after the flood had swept over, when kingship descended from heaven a second time, the kingship was in Kish. To modern eyes, the numbers are transparently mythic. No human reigns 800 years. Yet the structure of the story is telling. There is an earlier, exalted age under a divine kingship, then a great interruption, the flood, then a resumption. Kingship lowered again, now in new cities. The list is not just a genealogy. It is a claim that the political and religious order of the present is a restoration of something older and more sacred, broken and then renewed. This theme of recovery runs quietly through Sumerian culture. Their gods are not inventing crafts and institutions from nothing. They are the keepers and distributors of me, those tablets or decrees that embody the fundamental technologies and social structures of civilization. Kingship, priesthood, wisdom, craftsmanship, music, truth, writing. In myths, deities like Enki and Inanna barter, steal or redistribute these me between cities, explaining why one place rises as a cultural center while another declines. Implicit in the metaphor is the idea that the building blocks of complex society exist as a pre-given set, to be handed down or reallocated, not invented anew each time. When you see Uruk's explosion through that lens, it starts to look like a codification of older patterns. The sexagesimal system, for example, is startlingly well suited to astronomical observation and division of circles, things that sky priests and megalith builders further west had been grappling with in stone. Did Sumer's mathematicians pull base 60 out of nowhere? Or were they formalizing counting schemes and celestial cycles that had been carried in oral and ritual form for generations before anyone pressed them into clay? The same question applies to law and administration. The earliest tablets from Uruk and other Sumerian cities are not philosophical treatises. They are receipts. Lists of barley rationed to workers, records of fields, tallies of flocks. Behind such bureaucracy lies an already sophisticated understanding of property, obligation, time, and number. It is as if the scribes are catching up to a mental infrastructure their society already has, giving durable, transferable form to agreements and measures that had long existed in memory and spoken word. And all of this happens in a landscape shaped by water's long, capricious history. The southern Mesopotamian plain is the descendant of that drowned Persian Gulf Valley, a place where rivers have shifted courses again and again, where floods can erase boundaries overnight. To live there is to live with the constant possibility that the line between land and sea, house and river can move. Little wonder that Sumerian myths weave floods into their deepest origins, that their king list anchors legitimacy in a pre-flood age, that their gods control not just sky and earth, but the flow of the sweet waters beneath. If we imagine a line of continuity running from the sky-aligned stones of the early Holocene, through dispersed farming villages and regional shrines, to the temple complexes of Eridu and Uruk, Sumer begins to look less like the first light in a long night and more like the first rekindling after a series of extinguishings. The scribes and priests of these cities are not alone in their brilliance. They stand at the receiving end of a relay, knowledge passed hand to hand across catastrophes and migrations, now finally given a medium robust enough to survive the next deluge or the next dynasty. The fact that our written history starts there is partly an accident of preservation. Clay baked in Mesopotamian fires lasts. Wood rotted on drowned coasts does not. When we call Sumer the cradle of civilization, we may really be saying, this is the first cradle whose walls haven't washed away. In the context of a 30,000-year history gap, it is more accurate and somehow more moving to see Sumer not as our species' first awakening, but as a renaissance, the moment when enough fragments of older scattered insights were gathered and hardened in clay that the story could no longer be so easily erased. If Sumer is a renaissance, its gods are its inherited characters, figures who step onto the stage already heavy with meaning. In our own time, one group of them has been drafted into a very different script. The Anunnaki, recast as flesh and blood extraterrestrials mining gold and tinkering with human DNA. To see what we've really inherited from those early cities, we have to strip away that modern overlay and look at the Anunnaki as they appear in the oldest texts themselves. On Sumerian and Akkadian tablets, the Anunnaki are not spacefarers. They are a council. The word probably means offspring of Anu, or princely seed, the high gods descended from the sky father An. They sit in assembly, they debate, they pass decrees. They are numerous, not a small crew of astronauts, and they are tied to specific cities and cosmic domains. An is the distant patriarch in the highest heaven. Enlil is the lord of wind and authority, presiding over Nippur, stern and easily angered. Enki, Ea in Akkadian, is the clever one, lord of the subterranean waters and wisdom, patron of Eridu. Inanna, Ishtar, is the volatile goddess of love and war, protector of Uruk. The moon god Nana, the sun god Utu, the underworld queen Ereshkigal, all are part of this extended divine family. Their stories read less like technical manuals and more like court dramas. In the Atrahasis epic, for example, there is a labor dispute in heaven. The junior gods, the Igigi, are tired of digging canals and maintaining the cosmic infrastructure for the senior Anunnaki. They mutiny, surround Enlil's house, and throw down their tools. Enki proposes a solution: create a new being to bear the burden. With the mother goddess Nintu, he mixes clay with the flesh and blood of a sacrificed god, one who has intelligence. And from that mixture, humans are formed. Our purpose in that story is blunt. We are made to work, to farm, to build, and above all to provide food and offerings for the gods so they can rest. Later, when human numbers and noise grow too great, Enlil becomes irritated. He sends plagues and drought. Enki secretly helps people survive. Finally, Enlil decides on a flood to wipe them out, swearing the gods to secrecy. Enki sidesteps the oath by whispering the warning to a reed wall, knowing Atrahasis is listening. The man builds a boat, rides out the deluge, and repopulates the world. Afterward, a compromise. Shorter human lifespans, infertility, and social constraints to limit our numbers. Variations of this pattern appear again in the flood episode of the Gilgamesh epic, in other Mesopotamian texts, and in the Sumerian king lists talk of antediluvian kings and a world-resetting deluge. The Anunnaki are not benevolent creators in our image. They are powerful, capricious, sometimes cruel. They make us to serve, then nearly unmake us when we become inconvenient. Only the interventions of a sympathetic trickster god and a few warned humans preserve our line. If you strip away the modern gloss of ancient engines and landing pads, what remains is something deeply human. The Anunnaki behave like an exalted version of the elites Sumerians knew: kings, high priests, and great landlords. They control access to water and grain. They own the land. They command labor. They fight among themselves. They rewrite rules when it suits them. To people whose daily lives involve toiling in temple fields, delivering taxes and barley to bureaucrats, and living at the mercy of floods and droughts, it would be natural to imagine that above the visible hierarchy of palace and temple, there was an invisible one, just as arbitrary and overwhelming. In that sense, the myths turn social reality into cosmic law. If your king is distant and all-powerful because the gods made him that way, if the ration bowls and brick quotas are part of a divine order established when the me were apportioned, then resistance looks like rebellion, not just against men, but against the structure of the universe. At the same time, the figures of Atrahasis, Utnapishtim, and other flood survivors hint at another layer. These are culture bearers, people singled out for their wisdom or piety, entrusted with secret knowledge, instructed to preserve the seed of life through catastrophe. They build boats, store seeds and animals, and emerge into scoured landscapes carrying skills, memories, and perhaps texts. Around such individuals, real or imagined, legends accrete. Over generations, their human features blur. They become semi-divine, fused with the Anunnaki themselves. A distant ancestor who led a remnant through a real regional flood might, 1,000 years later, stand shoulder to shoulder with storm gods in the retelling. Seen from this angle, the Anunnaki are not aliens from another star system. They are projections of human power, fear, and memory onto the canvas of the sky. They crystallize the experience of living under absolute rulers and volatile environments. Their councils echo village assemblies and royal courts. Their quarrels over cities reflect actual political rivalries. Their use of floods and famines as tools of control mirrors the all-too-earthly ability of elites to unleash or withhold resources. Yet they may also carry, in highly mythologized form, fragments of older stories about times when knowledge kept a few alive through upheavals no one else understood. Pre-cataclysmic figures, master sky watchers, organizers of early dense communities, could easily be remembered as more than human by descendants who saw only their towering accomplishments, not the long learning that led there. Reframing the Anunnaki this way doesn't drain the magic from their tales. It relocates it. The true mystery is not that gods descended from the stars to create us, but that humans, emerging from repeated brushes with extinction, managed to imagine such intricate, morally charged universes at all, and to encode within them both their traumas and their social truths. In a mirror cracked by floods, fires, and forgotten cities, the Anunnaki are one of our oldest reflections. Distorted, magnified, draped in divine titles, but at heart still us, our rulers, our rebels, our saviors and oppressors, cast onto the vault of heaven so we could argue with them, plead with them, and in rare cases, defy them. If the Anunnaki have been recruited into a modern alien drama, one of their most important celestial concepts has suffered an even stranger fate. Today the word Nibiru conjures websites about hidden planets and doomsday flybys. But in the tablets left to us by the heirs of Sumer, the Babylonians, it meant something far more grounded and, in its way, more profound. To understand Nibiru, you have to see the sky the way a Babylonian temple astronomer did. Night after night, year after year, he climbs to the flat roof of the ziggurat with a stylus and a tablet. Above him, the vault is a black dome studded with points of light that rise and set in strict patterns. The fixed stars turn as a whole, circling the sky's pivot. The wandering planets move along a narrow band, the path of the sun, the ecliptic, sometimes advancing, sometimes seeming to pause or go backward. The moon swells and shrinks, racing through its own cycle. Every deviation, every eclipse, every odd grouping of planets is carefully noted. For the Babylonians, the heavens are not just pretty. They are the operating system of the world. In this cosmos, Nibiru is not a giant intruder from elsewhere. The Akkadian word Nibiru means something like crossing or ford, a place where paths intersect, a boundary or gateway. In their texts, it refers not to a single permanent object, but to a concept, a specific kind of position in the sky where important transitions occur. The key source is the Enuma Elish, the Babylonian creation epic. In it, after the storm, god Marduk defeats the chaos dragon Tiamat and fashions the universe from her divided body. He takes on the role of cosmic organizer. He sets up the stars as stations for the gods. He establishes the constellations of the zodiac. And he assigns a special place called Nibiru. He set up Nibiru to be the crossing place of the heavens. He fixed the zenith, the star of Marduk, that they might look upon it. Nibiru is the star which he caused to shine in the heavens. It is he who holds together the paths of the stars. In other words, Nibiru is a marker, a reference point by which the paths of other bodies are measured and kept in line. In some astronomical commentaries, Nibiru is explicitly identified as a star or planet associated with Marduk himself. Many scholars think this was usually Jupiter, the largest, most kingly of the visible planets, whose steady path along the ecliptic made it a natural emblem for the chief god. In some contexts, Nibiru may also denote the point where the sun crosses the celestial equator at the equinox, or the star that stands at the zenith at a crucial time, such as the summer solstice. The exact identification shifts because the underlying idea is relational, not object-based. Nibiru is the crossing, the place where heavenly routes meet, the celestial ferry that connects different regions of the sky. The god Marduk, as ruler, occupies that station and by doing so imposes order on what would otherwise be chaos. For Babylonian priests, such concepts were not abstract theology. They fed directly into the practical work of keeping the calendar on track and reading omens. Their astronomical compendia, the Emula-Pin series, the astrolabes, and later mathematical texts, list constellations rising and setting at particular times of year, track the periods of the planets, and give rules for predicting eclipses. Certain stars are assigned to the ways of Anu, Enlil, and Ea. Their risings and culminations are used to anchor the sky's coordinate system. Within this framework, a point like Nibiru would be crucial. If you know that at a given season, at a given hour of the night, a particular star or planet should be at the zenith or on the meridian, you can check whether the year's drift is accumulating. You can calibrate your luni-solar calendar, decide when to insert an intercalary month, time festivals, and anticipate when the sun and moon are most likely to meet in eclipse. You can also, according to their divinatory logic, interpret unusual departures from these expected patterns as messages from the gods about the fate of kings and kingdoms. So Nibiru was, at root, a technical term in a remarkably advanced science of the sky, a kind of celestial benchmark that connected mathematical regularity, ritual timing, and divine authority. It lived at the intersection of computation and myth. The irony is sharp. A word once used by careful observers to stabilize their understanding of the cosmos has become, in our age, a byword for destabilization. A phantom planet invoked to threaten our own. The crossing point that, in Babylonian thought, guaranteed that none might transgress or be neglectful of their proper courses is now imagined as a rogue body that will knock planets out of orbit. This inversion says more about us than about them. Where the Babylonians used Nibiru to tame a frightening sky, we use it to frighten ourselves with fantasies of secret collisions. Where they embedded it in a web of precise measurements, we detach it from evidence and cast it as a loose cannon. In doing so, we obscure something we should be admiring. The sophistication with which people, 4,000 years ago, turned patient sky-watching into a working celestial coordinate system tied to their most important social rhythms. Recovering Nibiru's original meaning is not just a matter of pedantic correction. It reminds us that our ancestors were not passively awed by the heavens. They were active model builders, encoding their understanding in names, in myths, and in the geometry of their temples. The same culture that gave us flood narratives and divine councils also gave us technical terms like Nibiru, quiet, precise tools in a cosmic toolbox. And it sets the stage for a larger tragedy we've already begun to glimpse. How the careful, often humble work of ancient sky science has, in modern imaginations, been twisted into stories of hidden planets and alien overlords. A term once used to hold the universe steady has become a symbol of fear that something's coming we're not being told about. To appreciate how far that distortion has gone and why, we have to leave Babylon's rooftops and return to our own, where different anxieties now drive us to project monsters into the same old sky. By the time the cuneiform tablets of Sumer and Babylon were pulled from the earth and translated, the world that made them was long gone. Their gods were museum pieces, their cities broken mounds. Into that silence, in the late 20th century, stepped a new storyteller with a very different script for the Anunnaki and Nibiru. Zecharia Sitchin was not a crank in a tinfoil hat. Born in what is now Azerbaijan, raised in Palestine, educated in economics, he was fluent in Hebrew and well-read in the Bible and Near Eastern history. In the 1970s, he began teaching himself Sumerian cuneiform and reading the emerging translations of Mesopotamian myths. What he saw in those wedge marks was, to him, not theology or metaphor, but journalism, eyewitness accounts of real events, just badly misunderstood. In his book, The 12th Planet, published in 1976, Sitchin laid out a narrative that would become one of the cornerstones of modern ancient astronaut lore. At its heart were three radical claims. First, he argued that the solar system contains an additional, undiscovered planet, which he equated with Nibiru. This world, he said, follows a vast, elongated orbit that takes 300-600 years to complete, looping from the outer darkness into the inner solar system and back. On each pass, it crosses the plane of the known planets, a literal crossing place, as the Akkadian word suggests. Second, he claimed that the inhabitants of this planet, the Anunnaki, were not gods at all, but a technologically advanced, long-lived humanoid species, facing a crisis in their own atmosphere. They allegedly came to Earth hundreds of thousands of years ago to mine gold, whose fine particles they could suspend to patch their sky. They established bases in what would become Mesopotamia and Africa, built spaceports, and set up a colonial administration. Third, to solve a labor shortage among their own ranks, Sitchin said the Anunnaki genetically engineered a new worker species by combining their DNA with that of a local hominid. Through in vitro fertilization and hybridization, they created Homo sapiens as a slave race. Over time, some Anunnaki mated with humans, producing demigods and heroes remembered in myth. Eventually, internal Anunnaki conflicts and global cataclysms, including a reinterpreted version of the flood, led to their departure or withdrawal, leaving us to muddle along with fragments of their knowledge. It is a heady story. It explains the sudden rise of civilization in Sumer as a gift or byproduct of alien tutoring. It reframes the Bible and Mesopotamian myths as garbled historical reports. It offers a concrete, physical origin for gods, angels, and Nephilim. And it taps into very modern veins of anxiety and desire. The feeling that we are being kept in the dark, that our true history has been hidden, that there are powerful, unseen forces behind our suffering. Millions read Sitchin's books. His specific claims about Nibiru's orbit and the Anunnaki's gold hunger spread into documentaries, late-night radio shows, and eventually the internet, where they fused with other apocalyptic narratives. By the time the 2012 panic rolled around, Nibiru was no longer a technical term from Babylonian astronomy, but a looming world of doom. But when you place Sitchin's readings next to the tablets themselves and the work of professional Assyriologists, cracks open. Scholars of Sumerian and Akkadian languages point out that Sitchin often stretches or alters meanings to fit his theory. The word Anunnaki, as we've seen, denotes a group of high gods, not a race from a specific planet. The term Nibiru, in surviving astronomical texts, functions as a reference point or crossing, not a constant label for a rogue world with a 3,600-year period. The famous cylinder seal he cited as a map of the solar system, VA 243, has been carefully re-examined. The sun with 11 planets he saw is more plausibly interpreted as a star symbol with surrounding decorative dots, a common motif. When Sitchin encounters myths about gods descending from heaven or riding the storm, he takes them literally as descriptions of spacecraft. Conventional philology reads them in the context of shared ancient metaphors, where heaven is a realm of the divine, not outer space, and storm and wind are stock images of power and movement. Where tablets describe temples as bond heavens or platforms of heaven and earth, he hears launch pads. Where Babylonian accounts speak of Nibiru determining the courses of the stars, he hears orbital perturbations instead of mathematical calibration. Astronomically, his Nibiru fares no better. A planet large enough to affect Earth on a 3,600-year elliptical orbit, diving into the inner solar system would leave unmistakable signatures in the movements of the other planets. Modern observations, from centuries of telescopic data to precision spacecraft tracking, show no such perturbations. Infrared sky surveys like WISE have ruled out Jupiter or Saturn-sized objects passing anywhere near on such timescales. The orbit he proposes is dynamically unstable. Over millions of years, gravitational interactions would likely eject such a body or crash it into another planet. Pointing these things out is not an attack on the human appeal of Sitchin's story. In a sense, he was doing what people have always done with gaps in knowledge, weaving them into a narrative that feels meaningful. Where ancient Sumerians looked up at impersonal floods and grinding hierarchies and imagined councils of gods, Sitchin looked at enigmatic myths, unexplained leaps in early civilization, and his own era's fascination with space and genetic engineering, and imagined ancient astronauts. His theory is, at bottom, another kind of myth-making, one that dresses itself in the language of science while departing sharply from its methods. It asks us to trust a single, idiosyncratic reading of ancient words over the accumulated, self-correcting work of an entire field, to prefer a dramatic, all-explaining story to the messier truth that many things in our past were invented by humans much like us, over long stretches of trial and error. Seeing this doesn't require cynicism. It simply broadens the pattern we've been tracing. In every age, humans confront the unknown, whether in the form of climate whiplash, vanishing giants, drowned coastlines, or undeciphered tablets. And we reach instinctively for stories big enough to hold our fear and our hope. Sometimes those stories take scientific form, grounded in evidence, tested and revised. Sometimes they take conspiratorial form, grounded in suspicion, resistant to correction. Both are attempts to impose order on a universe that has, more than once, taken us by surprise. In that light, Sitchin's leap from gods to astronauts is not an anomaly. It is our latest reflection in the old cracked mirror, a space-age echo of the same impulse that once turned kings into gods and floods into judgments, now turning ancient gods into aliens and lost planets into harbingers of doom. Strip away the imagined Nibiru, and you might think the sky is suddenly a calmer place. No hidden world on a collision course, no periodic intruder bringing floods and upheavals every few thousand years. But the real universe is not empty of mysteries. It has its own unseen planets and wandering worlds, just not the way the doomsday posters imagine. Start at the edge of our solar system, far beyond Neptune, in the Kuiper Belt. A vast ring of icy debris dwarf planets, and rock ice bodies orbiting in the deep cold. In the early 2000s, as astronomers cataloged more of these distant objects, they noticed something odd. A subset of them, on highly elongated orbits, many hundreds of astronomical units from the Sun, seemed to share a peculiar alignment. Their perihelia, the closest points of their orbits to the Sun, were clustered in a way that shouldn't happen by chance if they were randomly distributed. In 2016, planetary scientists Konstantin Batygin and Mike Brown at Caltech proposed a provocative explanation. An unseen planet, perhaps 5 to 10 times the mass of Earth, shepherding these far-flung objects into coherent paths through its gravitational influence. They called it Planet Nine, a hypothetical world orbiting so far out, hundreds of astronomical units away, that even our best telescopes might have missed it so far. Their calculations suggest Planet Nine would follow a long, stretched orbit, taking perhaps 10,000 to 20,000 years to circle the Sun. Crucially, though, it would never plunge into the inner solar system. Its aphelion, its farthest point, would be deep in the outer darkness. Its perihelion would still be well beyond Neptune, far too distant to pose any direct threat to Earth. Its presence would be felt only subtly in the slow tugs it exerts on Kuiper Belt objects over millions of years. The evidence is, as yet, circumstantial. Not all astronomers agree that the observed alignments require a planet. Some argue that observational bias, where and how we've looked, could produce similar clustering. Surveys like the Dark Energy Survey and upcoming telescopes like the Vera Rubin Observatory are expanding our reach and will test these hypotheses more rigorously. Planet Nine remains a ghost in the equations, not yet a point of light on a CCD. Zoom out further, beyond our solar system entirely, and you find a stranger population: rogue planets. These are worlds not bound to any star, drifting alone through interstellar space. Some may have formed in protoplanetary disks and been ejected by gravitational interactions. Others might be failed stars, brown dwarfs too small to ignite sustained fusion. Infrared surveys have identified candidates, objects with the mass of Jupiter or more, wandering between the stars. Statistically, there could be billions of such orphans in our galaxy. They are invisible to the naked eye, and almost all are so far away that even if they passed near our solar system in galactic terms, they would remain harmless, perturbing Oort cloud comets only marginally, if at all. Yet the idea of giant worlds adrift in the dark is potent fuel for imagination. It is easy to take a real phenomenon like rogue planets and, with a few speculative steps, turn it into a narrative about hidden destroyers. Even within known planetary systems, orbits can be more diverse and extreme than the neat, near-circular paths in our schoolbook diagrams. We've found exoplanets on highly elliptical orbits, hot Jupiters skimming just above their stars' surfaces, worlds in resonant chains tugging on each other, and systems that have clearly been reshaped by past encounters and migrations. The cosmos is not a clockwork of perfect circles. It is a dynamic, sometimes chaotic dance. The difference between these real mysteries and the fictional Nibiru is not that one is safe and the other dangerous, but how we approach them. Planet Nine is a hypothesis born from anomalies in data, framed in equations, and subjected to constant testing and revision. If future observations fail to find it or show that the Kuiper Belt alignments were an artifact of how we looked, the scientific community will, however reluctantly, let the idea go or modify it. Rogue planets are inferred from gravitational microlensing events and infrared glows, their numbers estimated with wide error bars that may shrink or grow as our instruments improve. Highly eccentric exoplanet orbits are reconstructed from wobbles in starlight and transit timings, then fed back into models of planetary formation. In each case, scientists are explicit about uncertainty. Papers include confidence intervals, alternative explanations, and caveats. The language is technical, sometimes frustratingly cautious to the lay reader. But that caution is precisely what distinguishes this kind of storytelling from the conspiratorial kind, where conspiracy narratives treat anomalies as proof of hidden certainties. They're hiding a planet. Science treats anomalies as clues in an ongoing investigation, always open to being reinterpreted in light of new evidence. And yet, the psychological pull is similar. Both tap into our discomfort with gaps. When we hear unseen planet, part of us leaps to fear or grandiosity. We imagine threats lurking just beyond our awareness or secret sources of our own uniqueness. The very idea that there could be a large, real planet in our solar system, still undiscovered by us in the 21st century, is humbling, almost humiliating. Some respond by doubling down on denial, others by inflating the unknown into a starring villain. The challenge is to acknowledge that humility without succumbing to either reflex. Yes, there may be a Planet Nine. Yes, the galaxy is full of rogue worlds. Yes, our models are incomplete. No, that does not mean an apocalypse is scheduled, or that every missing mass hides malevolent intent. In a way, the real rogue planets and hypothetical distant giants are more awe-inspiring than any scripted destroyer. They remind us that our solar system is just one outcome among many, that planetary architectures can take wild forms, that our stability is contingent, not designed. They urge us to keep looking outward with better tools and cooler heads. After all, if the history we've traced so far has taught us anything, it is that Earth has been blindsided before. Not by secret planets sneaking up from the dark, but by debris and dynamics we didn't yet understand. The right response to that realization is neither complacency nor panic, but the stubborn, patient work of mapping our cosmic neighborhood as it really is. So that next time, if there is a next time, we are less surprised. We don't need a hidden planet to live in danger. Our orbit already threads through a real hazard, a broad, ancient river of debris that wraps around the sun like a bandolier of stones. To find it, trace Earth's path through space over a year, then mark the points where, reliably, the sky seems to rain more fire. These are meteor showers. The Perseids in August, the Geminids in December, the Leonids in November. Each is caused by Earth, plowing through the dusty wake of a comet or asteroid. For a few nights, tiny grains strike our atmosphere at tens of kilometers per second, burning up as streaks of light, harmless fireworks. But not all streams are made only of dust. The Taurid meteor stream, named after the constellation Taurus, from which its meteors appear to radiate, is one of the broadest and most complex. We encounter it twice a year, in late June as the daytime Beta Taurids, and in October-November as the nighttime Taurids. To an observer on the ground, these showers are usually modest, slow, bright meteors, a few per hour. To an astronomer plotting orbits, the Taurids are the scattered remains of something once much larger. Dynamical studies suggest that 10 or 20,000 years ago, a giant comet, perhaps 50 to 100 kilometers across, entered the inner solar system and began to disintegrate. Tides, sunlight, and internal stresses cracked it apart. Dust, pebbles, boulders, and kilometer-scale chunks spread along its orbit, smearing into a wide stream. Over millennia, Jupiter's gravity tugged and stretched that stream into multiple filaments. Today, Earth's orbit intersects this diffuse band. Most years we pass through its sparser regions and see only the usual sprinkling of fireballs. But embedded within the stream, astronomers are finding something more ominous. Swarms of larger objects, tens to hundreds of meters across, whose orbits cluster in certain stretches of the Taurid path. They don't hit us every time. Their own positions precess and drift. But when their cluster and Earth's crossing line up, the chances of a serious impact spike. We have perhaps already had a warning of what even a modest fragment from such a stream can do. On the morning of June 30th, 1908, near the Podkamennaya Tunguska River in Siberia, the sky split open. Witnesses, reindeer herders and a few isolated settlers, reported a fireball brighter than the sun streaking across the heavens, followed by a series of deafening bangs and a shockwave that knocked people off their feet hundreds of kilometers away. In the epicenter, trees over an area of more than 2,000 square kilometers were flattened, all radiating outward from a central point. Forests burned, yet no crater was found. Modern reconstructions suggest a stony or icy body, perhaps 50 to 80 meters in diameter, entered the atmosphere at high speed, then exploded in an airburst at an altitude of 5 to 10 kilometers. The energy released was on the order of 10 to 15 megatons of TNT, hundreds of times the Hiroshima bomb. Had it detonated over a city, the result would have been apocalyptic on a human scale. Over remote taiga, it was a terrifying near miss. Its origin remains debated, but one leading hypothesis connects it to the Taurids. The timing, late June, matches Earth's passage through the daytime branch. Its trajectory and speed are consistent with Taurid meteoroids. If so, Tunguska was a single large pebble from a vast, smeared-out shoal of rubble we plow through twice a year. In the early 2000s, British astronomers Victor Klube and Bill Napier, among others, argued that the Taurid complex is the most serious long-term impact threat we face. Not because it hides a planet killer, but because its embedded larger fragments are numerous and poorly mapped. Some are known near-Earth asteroids, like 2004 TG10 and 2015 TX24, whose orbits trace the Taurid path. Others are suspected from statistical excesses of bright fireballs during certain years. Many more, if they exist, are still invisible to us. Dark rocks 100 meters across, too small and distant to catch with most surveys, unless we look in just the right place. What makes the Taurids unnerving is their combination of scale and recurrence. Unlike a one-off asteroid impact from a random direction, this is a hazard we repeatedly intersect on a fixed schedule. Most passes are benign, but every few centuries, perhaps, Earth's crossing happens to coincide with denser pockets of debris. In those epochs, the probability of Tunguska-class airbursts and even small cratering impacts rises sharply. If the Younger Dryas impact hypothesis is right, a much earlier, much denser phase of this same stream, or a sibling, may have delivered the multi-fragment bombardment that helped kick off that cold snap. Crucially, this is not settled fact. It is an evolving picture. Researchers are refining models of the Taurid complex, simulating its evolution, searching for larger bodies within it with telescopic surveys that target its orbital lane. The evidence is patchy, often indirect, always being re-evaluated. But the outline is clear enough to replace fantasy with a subtler, more sobering reality. We inhabit a planetary orbit that passes through a real shooting gallery, a band of debris left by a shattered giant. Most bullets are microscopic and make pretty streaks. A few are city killers. Very rarely, a cluster might contain continent-scale threats. We are only just beginning to map those bullets. A century ago, we didn't even know the Taurid's true nature. 50 years ago, we had no systematic sky surveys for near-Earth objects. Today, we track tens of thousands, but our coverage is still incomplete, especially for small, dark bodies coming at us from the direction of the sun. In this light, the real danger is not a secret planet hidden by conspirators, but rocks we haven't yet found because we haven't looked hard enough. The minefield is real. Our ignorance of its largest mines is, for now, the scariest part. The Taurid stream reminds us that cosmic danger is not a one-time event tucked safely in the distant past. To see how often Earth has been jolted and how human societies respond, we have to zoom through the last few thousand years, watching our own civilizations wobble and sometimes fall. Start around 1200 BCE in the Eastern Mediterranean. This is the Late Bronze Age, a glittering web of palace cultures. Mycenaean Greece, Hittite Anatolia, New Kingdom Egypt, the city-states of Canaan, the trading empire of Ugarit. They exchanged tin and copper for bronze, grain for timber, luxury goods for horses and chariots. Letters scratched in Akkadian cuneiform sail between courts, sealed with royal names. Then, within the span of a few decades, that network unravels. Palaces burn. Ugarit is destroyed so suddenly, its last tablets, mentioning invading ships, are left unfired on desks. Hattusa, capital of the Hittites, is abandoned. Mycenaean fortresses are sacked. Egyptian inscriptions speak of sea peoples ravaging coasts, of famine, of whole lands reduced to waste. Archaeologists point to a complex tangle of causes. Droughts that strained food supplies, earthquakes along plate boundaries, internal rebellions, invasions by migrating groups armed with iron weapons. Overlaying this is evidence of climatic disruption around the same time. Pollen records showing drying conditions, sediment cores indicating reduced Nile floods. Some researchers have suggested that bursts of high-altitude dust in ice cores from Greenland, dated roughly to this era, hint at volcanic eruptions that could have triggered short-term cooling and crop failures. Others have speculated, more tentatively, about meteoritic inputs, but here the evidence is thin. What's clear is that a set of environmental stresses, whether purely terrestrial or with cosmic nudges, cascaded into political and social collapse. Jump forward to around 4,200 years ago, roughly 2200 BCE. Globally, something goes wrong with the water. In Mesopotamia, the Akkadian Empire, first to unite much of the Fertile Crescent under one ruler, falters. Texts speak of failing harvests, people selling children for grain, cities abandoned to encroaching desert. To the west in Egypt, the Old Kingdom, the age of the Great Pyramids, gives way to a period of fragmentation and famine known as the First Intermediate Period. Farther east, in the Indus Valley, urban centers show signs of stress and depopulation. In China, the archaeological record hints at disruptions in Neolithic cultures along the Yellow River. Sediment cores from lakes and oceans, stalagmites from caves, and dust layers in ice all converge on a major climate anomaly. A rapid shift toward aridity in many regions, known as the 4.2 kilo-year event. Monsoon patterns changed, rainfall belts moved, rivers shrank or shifted course. Civilization's early heartlands, dependent on delicate balances of flood and drought, reeled. Here, mainstream explanations focus on natural variability in Earth's climate system. Changes in solar output, ocean circulation, atmospheric circulation. Some fringe views have suggested that extraterrestrial dust influx, perhaps from a cometary source, could have played a role in altering insolation or seeding clouds. But the evidence is, again, circumstantial. The important point is the pattern. A relatively short climatic jolt triggers widespread societal adaptation and, in some cases, collapse. Myths from later periods, about kings who lost divine favor, about rivers that ran dry, about golden ages ending in want, may carry distant memories of those lean centuries. Now leap ahead to the 6th century CE, into a world of Byzantines, Sassanid Persians, and post-Roman kingdoms. In 536, historians like Procopius record that the sun gave forth its light without brightness, like the moon, during the whole year. Chinese chronicles speak of yellow dust and summer frosts. Irish annals note a failure of bread. Tree rings from Europe and Asia show stunted growth, indicating one of the coldest decades in the last 2 millennia. Ice cores from Greenland and Antarctica contain layers loaded with sulfates, signatures of volcanic eruptions, around 536 and again in 540, 541. Modern analysis points to a pair of massive volcanic events, likely in the tropics, that injected huge amounts of aerosol into the stratosphere, dimming sunlight and cooling the planet for years. The immediate effects were failed harvests, famine, and social stress. Shortly after, the Justinianic plague, the first recorded pandemic of bubonic plague, swept through the Mediterranean and beyond, exploiting weakened populations. Some researchers see this late antique Little Ice Age as a pivotal shock that further battered an already fragile post-Roman world. Yet even here, hints of additional atmospheric disturbances lurk. Certain ice core layers in this era also show spikes in nitrates and other compounds often associated with solar proton events or large meteoritic air bursts. The evidence is not definitive, but it raises the possibility that the mid-6th century was a time of compounded insults. Massive eruptions, possible solar storms, maybe even small impacts, all converging on societies that then encoded their suffering in apocalyptic language. Across all these episodes, a pattern emerges, not of a single cause, but of recurring shocks, some purely terrestrial, some possibly with cosmic components. Tree rings capture years when growth faltered. Ice cores trap layers of ash, dust, and chemical anomalies that mark sudden injections into the atmosphere. Sediments record floods and droughts. Archaeological layers witness abrupt abandonments, burn layers, shifts in diet and burial customs. Cultures respond in ways that are, by now, familiar. They tighten hierarchies or fracture into smaller polities. They move, migrating toward still fertile lands, away from coasts or rivers that have become unreliable. They elevate new religious movements that promise explanations and remedies, or reinterpret old myths in light of new catastrophes. Importantly, not every collapse has a cosmic fingerprint. Many can be fully explained by plate tectonics, volcanic cycles, internal politics, and the inherent instability of complex systems. To claim that every downturn came from the sky would be to repeat the same error as the most imaginative catastrophists, forcing all anomalies into a single narrative. But to ignore the sky's occasional role would be equally misleading. The Younger Dryas, whatever its exact trigger, shows that cosmic and climatic forces can intersect to reshape the baseline conditions of life. The Taurid stream and Tunguska remind us that the bombardment environment has not turned off. The Late Bronze Age, the 4.2 kiloyear event, and the 6th century dust veil illustrate how even less extreme perturbations, volcanic or otherwise, can topple intricate human arrangements. Again and again, Earth has been shaken. Again and again, our cultures have staggered, adapted, and then told stories about what hit them. Gods withdrawing favor, stars falling, suns dimming, ages ending. In those overlapping narratives, ice and ash on one side, myth and chronicle on the other, we can start to see a deeper truth. Civilization is not a straight, unbroken climb. It is a series of climbs interrupted by slips, some from our own missteps, and some from pebbles or boulders, or veils of dust thrown into our path by a larger, indifferent cosmos. If repeated shocks and slow drownings shaped our early millennia, it is no surprise that some of our most enduring stories are about worlds that sank. Among them, none is more famous than Atlantis. We know Atlantis not from ancient maps or inscriptions, but from a pair of dialogues written by Plato around 360 BCE, the Timaeus and the Critias. There, through the voice of Critias, Plato tells of a great island empire, beyond the Pillars of Heracles, beyond the Strait of Gibraltar, larger than Libya and Asia Minor combined. Its people, descended from Poseidon, an immortal woman, built concentric rings of land and sea, temples sheathed in orichalcum, and a navy that subdued many lands. Grown arrogant, they attacked virtuous Athens. The gods punished them. In a single day and night of misfortune, the island of Atlantis, in like manner, disappeared in the depths of the sea. For centuries, thinkers treated Atlantis as allegory, a moral fable about hubris and ideal states. But its specificity, the mention of real peoples and places, its sudden annihilation by flood and earthquake, have tempted many to read it as garbled history. Proposed locations proliferate: the Azores, the Caribbean, the Black Sea, Santorini, even Antarctica. Each theory tries to match elements of Plato's description to a real geography and a known catastrophe, often the Bronze Age eruption that shattered the Aegean island of Thera. Step away from the hunt for a single Atlantis, though, and another pattern appears. Stories of lost homelands drowned by the sea are everywhere. In Mesoamerica, some Aztec origin myths speak of Aztlan, a place of white herons and 7 caves, an island or coastal region to the north from which their ancestors set out. Later accounts describe it as a paradise, abandoned or destroyed, across waters that could no longer be crossed. In Andean lore, the god Viracocha emerges from the waters of Lake Titicaca after a flood has cleansed the world, then creates new peoples. Farther north, along the coasts of what is now Canada and Alaska, some indigenous narratives tell of villages washed away by waves that came farther and higher than any before, leaving only a few survivors on the hills. In the Indian Ocean, Tamil legends speak of Kumari Kandam, a vast land south of India where a great civilization once flourished before it was swallowed by the sea. In Southeast Asia, tales circulate of kingdoms beneath the waves, temples now visited only by divers and fish. The Greeks themselves had older stories of sunken Bronze Age cities like Helice, destroyed by earthquakes and engulfed by the Corinthian Gulf, real events now corroborated by underwater archaeology. What if, instead of searching for one lost supercontinent that explains all these legends, we see them as poetic compressions of many different losses along many different coasts? Between 20,000 and 7,000 years ago, global sea level rose by more than 100 meters. It did not do so in a smooth line. There were pulses, centuries when it climbed much faster than average, when ice sheets released great surges of meltwater. Each pulse would have translated, locally, into generations watching the shoreline creep inland, estuaries eat fields, storms gnaw at barrier islands. Every few human lifetimes, a village that once seemed safely inland might find itself abruptly at risk. From the standpoint of one person's life, the change is slow. You move your houses a little higher, rebuild your fish traps farther up the estuary. But over the span of ancestral memory, stories that reach back 7 grandfathers or 20 generations, it can easily be compressed into one narrative arc. Our people came from a place out there. It was taken by the sea, We survived by doing this. The details blur. The core emotion does not. Archaeology is beginning to find hints that some of these tales are anchored in real drowned landscapes. The Halik of legend has been located under sediments in the Gulf of Corinth, its walls and streets preserved as a Hellenistic Pompeii. Off India's coast, sonar surveys have revealed rectilinear features and submerged structures near old river mouths, though their age and significance are still debated. Boldner Cliff, off southern England, has yielded Mesolithic wooden platforms and tools 11 millennia old, now in 11 meters of water. In the North Sea, cores bring up peat, animal bones, and flint tools from Doggerland's former forests and marshes. These are not Atlantean metropolises with crystal power plants. They are ordinary habitations, fishing camps, small villages. Yet for the people who lived there, their loss would have been world-shattering. A flood that sweeps through in a single terrifying storm, perhaps aided by a storm surge, a tsunami from a submarine landslide, or a siege in a narrowing basin, could erase not just buildings, but landmarks, burial grounds, sacred groves. Survivors on the surrounding hills would carry that trauma into story. Over centuries, as memories travel and merge, as bards embellish and philosophers repurpose, many local catastrophes can fuse into the idea of one archetypal lost world. Plato, drawing on older Egyptian tales and perhaps on real memories of Mycenaean palaces and Thera's eruption, recasts them into Atlantis, a morality play for his Athens. Aztec priests, consolidating diverse tribal histories, speak of a single Aztlan. Tamil poets, feeling the weight of southern India's drowned shelves, imagine Kumarikandam. The psychological mechanism is the same one we've seen before. Cultural grief, the pain of losing a homeland, a way of life, a shoreline that anchored identity, seeks a form big enough to hold it. A myth of a single perfect realm, taken in one terrible night by an angry ocean, is more narratively satisfying than a slow, complicated history of erosion, subsidence, and incremental retreat. It gives the loss a reason, even if that reason is moral failure. None of this means there were no remarkable coastal cultures on those now submerged plains. On the contrary, the richness of the myths hints that there were many, each with their own achievements, now largely unrecorded in stone. But it does suggest that our longing for Atlantis, the hope that we can find one city, one catastrophe that explains our amnesia, may itself be a kind of amnesia. It simplifies a long, devastating process into a single image. Towers sinking beneath waves. If we listen closely, the world's sunken land stories do not all point to the same coordinates. They point instead to a band around every continent, where people once lived and watched the sea take what they had built. They are, collectively, the elegy of the drowned margins of our world, sung in different languages, but harmonizing on the same refrain. We had a home out there, and it is gone. Walk inland from any of those drowned shores, up into highlands and plateaus, and you eventually meet another kind of enigma. Stones so large and so precisely set that standing before them, you understand why some people reach for extraterrestrials. The stones themselves invite the word impossible. In Lebanon's Bekaa Valley at Baalbek, the Roman temple complex of Jupiter sits atop something older, a massive stone platform. Along its western wall are 3 blocks, the Trilithon, each over 19 meters long and weighing around 800 tons. Nearby in the quarry lies an even larger monolith, over 1,000 tons. No ancient text explains how they were moved and set. Engineers point to sledges, rollers, levers, human and animal muscle, perhaps aided by ramps and counterweights. The solutions are plausible, but the visceral shock remains. At some point, someone decided that building with stones the size of small houses made sense. Half a world away, above Cusco in Peru, the Inca fortress of Sacsayhuaman crowns a ridge with zigzag walls of tightly fitted polygonal blocks. Some weigh over 100 tons, their faces bulging slightly, their joints interlocking with bewildering complexity. You can't slip a blade of grass between them. Cut surfaces meet in irregular, jigsaw patterns. The effect is both organic and engineered, like a cliff that learned geometry. At Puma Punku, a part of the Tiwanaku complex near Lake Titicaca, low platforms and scattered blocks hint at an earlier monument. Here, the stone is not cyclopean in size, but in precision. Andesite and sandstone blocks bear right angles so sharp they look machined, with grooves and notches that suggest modular assembly. Some surfaces are finished to a near polish. The site has been heavily quarried and altered, but even in ruin, its craftsmanship is startling. Add other sites to the tour, the so-called Cyclopean walls of Mycenae and Tiryns in Greece, with their huge, roughly shaped but tightly stacked stones, the Nuraghe towers of Sardinia, the dolmens and passage graves dotting Europe and Korea, the stepped platforms and retaining walls of pre-Columbian Mesoamerica and Polynesia. Different cultures, different times, different aesthetics. But certain motifs recur. Large, irregular stones fitted without mortar into walls that can flex during earthquakes. Courses of smaller, regular blocks above broader, heavier foundations. Tendency to overbuild, using blocks far larger than strictly necessary for the loads involved. Sites placed with attention to horizons, solstices, or sacred mountains. In some cases, underground drainage and clever water management hidden beneath monumental facades. In others, double walls with rubble cores or interlocking stone quays tying faces together. Mainstream archaeology, which has actually spent decades in the trenches at these sites, is less baffled than the internet comment sections. Experimental archaeology has shown that with enough people, rope, wood, and time, very large stones can be quarried, shaped, moved, and set without pulleys or steel. Egyptian obelisks were raised using earth ramps and counterweights. On Easter Island, researchers walked replica Moai statues by rocking them side to side on ropes. In Peru, local stonemasons still demonstrate traditional techniques for shaping and fitting blocks using hammerstones and abrasion. The point is not that such feats were easy. It's that they were possible with the technology and social organization available. The real mystery is not how, in a mechanical sense, these monuments were built. It's why similar strategies appear in widely separated places, and why certain high-end building techniques show up almost fully formed, with few obvious trial-and-error predecessors in the surviving record. One tempting answer is independent invention. Given earthquakes, heavy rain, and the desire to impress or intimidate, many societies will converge on similar engineering solutions. Polygonal masonry, for instance, is particularly good at dissipating seismic energy. Its irregular joints prevent long, straight cracks. Massive foundations anchor structures against subsidence and erosion. Aligning sacred buildings to celestial events is a natural extension of skywatching. Another, subtler possibility is cultural diffusion across more generations, routes, and disasters than we usually consider. Techniques can spread not just by direct contact between big empires, but via chains of local exchanges. A stonemason in one valley learns a trick from a traveler whose great-grandfather fled a collapsed city 2 countries away. A certain way of undercutting joints, a preferred notch shape, a rule of thumb about wall batter spreads like a craft meme. Over thousands of years, through rises and falls, these memes can move surprisingly far, especially when carried by deeply rooted roles. Builders, priests, astronomers. When catastrophes erase cities, the knowledge in those specialists' heads may be one of the few things that escapes, walking on two legs into the next chapter. In that framework, Baalbek's platform, or Sacsayhuaman's walls, are not lone miracles. They are high points of a much longer, mostly hidden experimental tradition in stone, just as Sumer's writing is the visible tip of a long development in account-keeping. Earlier iterations may have crumbled, been robbed for later building, or lie underwater. We see the surviving masterworks and assume they sprang fully formed from nothing because their prototypes are gone. This doesn't require aliens. It does require us to credit ancient engineers with iterative, cumulative thinking, and to accept that their lineage may stretch back beyond the official start lines of civilization. The repeating design languages across continents, careful jointing, overbuilt foundations, celestial alignments, look less like evidence of a single lost global superculture, and more like the echo of shared constraints and slowly diffusing best practices. Emotionally, though, walking among those stones feels like stepping into a conversation already in progress. You sense layers, a latest rebuilding atop an earlier foundation, atop something older still. You feel the presence of many anonymous hands, refining, inheriting, and sometimes misunderstanding techniques, whose original inventors are long gone. The monuments that remain are not impossible. They are improbable survivors of a long chain of trial, success, failure, and forgetting, a chain that likely extends deep into the 30,000-year history gap we're trying to illuminate. Among the Cyclopean stones and drowned coasts, another repeated motif appears, not in rock, but in story. When ancient peoples are asked how they learned to write, to plant, to build, to count the stars, they often do not say, "We figured it out ourselves." They point instead to visitors. In Egypt, that visitor is Thoth. Depicted as an ibis-headed or baboon-headed god, he is the divine scribe, master of hieroglyphs, keeper of time, patron of astronomy, mathematics, and medicine. In temple inscriptions, it is Thoth who gave writing to mankind, who recorded the verdicts of the divine court, who measured the heavens and fixed the calendar. Kings sometimes claim to have received their knowledge directly from him. Laws, rituals, the secrets of sacred architecture. On the far side of the Atlantic, in Mesoamerica, a very different figure plays a similar role. Quetzalcoatl, the feathered serpent. Among the Toltecs and later the Aztecs, he is both god and culture hero, a bringer of maize, calendar lore, and crafts. Some traditions describe him in human form as a fair-skinned, bearded man who came from the east, taught for a time, and then departed over the sea, promising one day to return. How much of that description is pre-Columbian and how much is post-conquest distortion is debated, but the core idea of an outsider teacher remains. In the high Andes, the Inca told of Viracocha, the great creator who, after a devastating flood, wiped out an earlier race of giants, brought forth a new humanity from caves and stones. He walked among them in human guise, a man of middle height, white and dressed in white. With a beard, again, a detail that may or may not be original, teaching them agriculture, arts, and laws, before departing across the Pacific, walking on water, never to be seen again. Back in Mesopotamia, a series of figures called the Apkallu, the sages, stand between gods and humans. One of them, Oannes, in later Greek retellings, was described by Berossus, a Babylonian priest writing in the 3rd century BCE, as a being who rose from the Persian Gulf in antediluvian times. His body was fish-like, but underneath was a human form. By day he dwelt among men, teaching them writing, mathematics, agriculture, and the foundations of civilization. At night, he returned to the sea. Several Apkallu are named in earlier Sumerian and Akkadian sources, each associated with a specific city and body of knowledge, all linked to the period before the flood. These are just a few examples. In Polynesia, there are culture heroes like Maui, who fishes up islands and slows the sun. In North America, figures like Glooskap or Nanabojo teach survival skills and moral law after periods of chaos. In India, Manu is warned of the flood by a talking fish who also instructs him. Across cultures, these bringers of knowledge share traits. They appear suddenly, often from the sea or from the east. They arrive in times of disruption or shortly after world-reshaping events. They teach core skills, and they eventually leave, sometimes with a promise to return. One reading, the modern one made famous by ancient aliens narratives, is to take these descriptions literally and extraterrestrially. Beings who arrived from the sea become astronauts from starships, shining garments become suits, boats or fish bodies become craft. But we don't need to leave Earth to find a more grounded and perhaps more poignant possibility. Imagine instead a world staggered by environmental catastrophe, rising seas, failed rains, shifting seasons. Populations are fragmented, knowledge scattered. In some, refuges, better sheltered valleys, inland oases, upland basins, groups have managed not only to survive, but to maintain a higher level of organization and learning. Better farming techniques, more stable food storage, an oral tradition of star cycles. Maybe even the remnants of a writing system in knotted cords or carved marks. Individuals from such centers, whether out of altruism, trade interest, or necessity, set out into the wider, broken landscape. To people in more devastated areas, they would look and sound extraordinary. They might speak a different dialect, wear different clothes, possess artifacts unfamiliar to locals, metal tools when only stone is known, or simply a knack for prediction that seems uncanny. Plant when that star rises there, not when the rains used to come. They might seem old beyond their years, carrying stories from a time before the disaster as if from another world. If they come by boat along coasts that have recently shifted, or up rivers whose mouths are now farther inland, it would be natural to say they came from the sea. If they stay for a generation or two, teach, then leave, or their line dies out, or they are killed, the memory condenses into a single, semi-divine figure. Over centuries, accretions of symbolism turn a band of traveling agronomists and priests into Quetzalcoatl, Viracocha, Oans. Even without a global super-civilization, smaller, regionally advanced societies could have filled this role repeatedly. Their emissaries, fleeing conflict or environmental decline at home, might have seeded ideas along their routes. Over the long term, we would expect the fine details of their origin to vanish, leaving only the archetype, the stranger teacher emerging after chaos, giving the gifts that define a culture, then disappearing beyond the horizon. Critically, this doesn't require that any one mythic figure correspond to a single historical person. Like flood stories, culture bringer stories can be composites. Half-remembered ancestors, traveling craftsmen, conquered elites folded into one narrative persona. What matters is the pattern they encode. That people, after crisis, often perceive key innovations, writing, law, timekeeping, not as incremental local inventions, but as revelations brought from outside. Seen together, These myths paint a haunting picture that resonates with the 30,000-year history gap we've been tracing. Not of alien god kings descending from starships, but of human hidden teachers walking through post-cataclysmic ruins. A handful of survivors from pockets where knowledge persisted, moving along rivers and coasts, carrying fragments of an older world into a newer, more precarious one. Their footsteps are lost. Their names, if they ever existed as individuals, have dissolved into god names and hero tales. But the roles they play in our oldest stories suggest that, somewhere in our deep past, real people stood at the edge of shattered landscapes and chose to teach, rather than merely endure. In the long relay between catastrophe and civilization, they may have been the crucial middle runners, passing a torch that without them might have gone out. If hidden teachers once walked a shattered world, they did so with brains wired by something more than everyday survival. To understand why our species is so obsessed with pattern, story, and foreseeing danger, we have to look not just at stones and myths, but at neurons. What does it do to a mind to live, generation after generation, on the edge of erasure? In evolutionary terms, Homo sapiens is young. Our species appears in Africa perhaps 300,000 years ago. For much of that time, our ancestors lived in small, mobile bands, hunting and gathering, navigating shifting climates. Our brains, their size, basic architecture, were already in place long before the Younger Dryas or the first cities. But how those brains were used, what cognitive styles were favored, may have been sharply shaped by episodes of acute stress. Neuroscience and evolutionary psychology give us one key: plasticity under pressure. In individuals, we know that moderate, intermittent stress can enhance learning and memory. A brain confronted with changing conditions is forced to update models, discard old expectations, and form new associations. Too much stress, too fast, simply breaks things. Trauma, paralysis. But at the population level, over many generations, environments that are unpredictable yet survivable tend to reward certain traits. Flexibility, creativity, long-range planning, social cooperation, and an ability to simulate futures in imagination before they happen. Look again at the archaeological record through that lens. The first clear bursts of symbolic art, engravings, beads, painted caves, often cluster around the times after major climatic or ecological shifts. In Africa, sophisticated engraved ochres and personal ornaments appear in the wake of harsh glacial intervals and changing coastlines. In Europe, the sudden flowering of cave art, portable sculptures, and musical instruments around 40,000 years ago coincides with modern humans moving into new, challenging environments and encountering Neanderthals. Then, much later, in the 30,000-year gap we've been tracing, we see repeated patterns: complex toolkits, long-distance trade in exotic materials, elaborate burials, and communal architecture emerging or intensifying after environmental jolts. After the Younger Dryas, when climate stabilized into the Holocene, there is an explosion of new behaviors. Gobekli Tepe's stone sanctuaries, early agriculture in multiple centers, rapid increases in population and social complexity. It is as if the pressure cooker of the late Ice Age and its wild swings primed our species for a phase transition, in cognition as much as in culture. Inside the skull, the machinery that supports this shift is costly. Brains are metabolically expensive. In humans, they use about 20% of our resting energy. A larger, more energy-demanding cortex pays off only if it confers enough advantage to offset its fuel bill. Periods of relative environmental stability may not reward extra cognitive horsepower. rote habits and local knowledge suffice. But when your world's rules keep changing, when prey vanish, weather patterns flip, rivers reroute, coastlines drown, the individuals and groups that can generate novel solutions, share them, and plan ahead gain a huge edge. Those capacities map onto traits we recognize as hallmarks of modern cognition: symbolic thought, language rich in metaphor, causal reasoning, the ability to imagine counterfactuals. What if we tried this? And an extended sense of time. They also map onto our vulnerabilities: anxiety about the future, obsession with omens, the urge to explain misfortune even when the cause is random. From this perspective, catastrophe is both destroyer and midwife. It wipes out entire cultures, narrows genetic diversity, erases knowledge. But it also creates selection regimes favoring those whose neural wiring leans toward abstraction and prediction. A band that can read the sky's subtle cues, remember the last time smoke dimmed the sun, or infer from distant thunder that a flood is coming, stands a better chance of surviving and passing on its cognitive style. Social complexity is part of this story too. Under pressure, cooperation can be more adaptive than pure competition. Large game hunts, long-distance trade, shared irrigation systems, and communal building projects like megaliths or levees all require coordination, rules, and trust. That selects for minds capable of perspective-taking. What is she thinking? Norm enforcement. We all agreed to do this. And the construction of shared narratives that bind groups together. We are the people who came from X, saved by Y, destined for Z. Those narratives, in turn, become the vessel in which memories of real disasters are stored. A brain primed by evolutionary history to seek patterns will look at a random sequence of good and bad years and still find cycles. Sometimes that leads to genuine insight, recognizing seasonal or astronomical rhythms. Sometimes it leads to seeing agency where there is none. Angry gods, malevolent stars, curses. But even wrong stories can be adaptive if they preserve useful caution. Do not build there. Do not ignore that kind of sky. Do not cut down that grove. Modern neuroscience has a term for our tendency to overdetect patterns and agency. Hyperactive agency detection. In a predator-rich world, it is safer to mistake the wind in the grass for a lion than the other way around. Scale that up to cosmic disaster, and you get a species that would rather imagine a council of offended gods or a returning planet than accept that sometimes rocks just fall from space. The 30,000-year history gap, then, is not just a missing chapter in our external record. It is the crucible in which our internal biases were forged. Our brains are the descendants of those who made it through ice ages, sudden droughts, roaring fires, and rising seas. Not by being the strongest or the fastest, but by being the most obsessively curious, anxious, and creative. That inheritance is double-edged. It gives us science, art, long-term planning, and the capacity to build planetary-scale civilizations. It also gives us apocalyptic fantasies, conspiracy theories, and a chronic sense that something terrible might be about to happen. Seen in that light, our recurring stories of floods, lost worlds, hidden teachers, and rogue planets are not aberrations. They are the natural output of a mind evolved under repeated existential alarms. A mind that, once burned by the sky, never forgets to glance upward, just in case. If our minds were forged in crisis, the planet kept the receipts. To see them, we have to leave stories and cities behind and descend into quieter places. The deep ice, the layered rock, the dust of ancient lakebeds. Here, time is not remembered, but recorded. In Greenland, on a high, blindingly white plateau, a cluster of low buildings huddles against the wind. Inside In a chilly, humming warehouse, long cylinders of ice lie stacked in insulated racks. Core segments, each about a meter long, labeled with depth and date. Scientists in parkas and gloves move among them like librarians in a frozen archive. Each core is a vertical slice of history. Snow falls on the ice sheet every year, compacting under its own weight, turning by slow degrees into firn, then ice. Tiny bubbles of air are trapped as it densifies, preserving samples of the atmosphere as it was when the snow fell. Dust blown from distant deserts, ash from volcanic eruptions, salt from sea spray, soot from fires, all settle with the snow, forming microscopic layers. Drill down 2 kilometers and you've effectively drilled back more than 100,000 years. On a bench, under bright lamps, a researcher saws a core segment into thin strips. One goes to a mass spectrometer, which measures the ratios of oxygen and hydrogen isotopes. Those ratios shift with temperature, giving a record of how warm or cold the world was when that snow fell. Another strip goes to an ion chromatograph, which detects sulfate, nitrate, chloride, calcium, chemical fingerprints of volcanic eruptions, biomass burning, sea ice extent. A third strip is melted into a continuous stream, analyzed in real time for trace gases: methane, carbon dioxide, nitrous oxide. On a graph, the results form lines, jagged, looping, spiking lines that trace glacial and interglacial cycles, abrupt warmings and coolings, volcanic winters and greenhouse rises. The Younger Dryas shows up as a sharp, cold sawtooth. The 4.2 kilo-year event appears as a subtle kink. The 6th century dust veil is a pair of abrupt sulfate spikes. In some layers, tiny, inclusions of microscopic spherules, elevated platinum, and other anomalies hint at meteoritic inputs. Half a world away, in Antarctica, similar labs hum at the bottom of the world. Here, the ice is older and cleaner. Cores like Epica and Dome C reach back 800,000 years, encompassing multiple ice ages. The bands are fainter, the snow accumulation slower, but the story is the same. Year on year, the planet's heartbeat written in frozen water. Between the 2 poles, in mountains and mid-latitudes, stone does a related job. On the flanks of a long, quiet volcano, a geologist stands before a cliff where alternating bands of ash and lava are exposed. Each eruption laid down a distinctive layer. Coarse pumice here, fine ash there, darker, denser flows of basalt in between. Over time, sediments washed in, soils formed, rivers cut channels. The stack of layers, once horizontal, has been tilted by tectonic forces, now presented like pages in a book. By sampling these layers and dating them, using radiometric methods on zircon crystals, for example, scientists build timelines of volcanic activity. In some cases, they tie specific ash layers to those found in ice cores or lake beds thousands of kilometers away, linking a violent eruption to global climate impacts. In lake sediments, annual layers called varves, light and dark bands of silt and organic matter, accumulate like tree rings. Cores from such lakes can be counted back, year by year, for tens of thousands of years. Embedded pollen grains tell which plants were growing when. Charcoal flecks speak of fires. Changes in grain size reflect floods and droughts. All these archives, ice, ash, mud, are different expressions of the same principle. The planet cannot help but record its own changes. It has no consciousness, no plan. Yet every snowfall, every eruption, every flood leaves a trace. Unlike human memory, which compresses, embellishes, and forgets, these records are bluntly literal. They do not tell us why in terms of motives, only what and when in terms of conditions. Standing in an ice core facility or on a stratified outcrop, you feel a particular kind of humility. The scale is dizzying. That faint shift in isotopes at a depth of 1,600 meters marks a cold snap during which no one yet farmed, but our ancestors painted caves. That bright sulfate spike aligns with a medieval chronicles note about a year without summer. That thin dusting of micro-charcoal corresponds to a myth from half a world away about the time the forests burned. For a long time, these ledgers lay unread. Only in the last half-century have we developed the tools to extract and decode them. Before that, we had only myths, chronicles, and the fragmentary bones and tools in the ground. Now, for the first time, we can look at an ice core graph and a flood story, a ring in a tree, and a king list, and see where they line up and where they part ways. It does not demote the myths to know that the ice tells a complementary tale. If anything, it deepens them. When a text speaks of 7 years of famine, and we see a cluster of cold, dry summers in the relevant layer, the story gains context. When a tradition remembers a darkened sun, and the ice shows a massive eruption or a spike in atmospheric dust, the planet itself corroborates the human shiver. The 30,000-year history gap we've been circling is no longer utterly dark. Between the myths of floods and gods and the physical traces in ice and stone, a dim landscape is coming into view. Cold snaps and warmings, fires and drownings, rises and falls of unknown peoples. We may never know all their names or the full detail of their lives. But by reading the planet's ledgers alongside our own stories, we can at least begin to see the rhythms we share. Our ancestors, staring at inscrutable skies and treacherous rivers, did the best they could with narrative and ritual. We, with spectrometers and scanning microscopes, do the best we can with data. In the end, both are attempts to answer the same questions. What happened to us? Will it happen again? And if it does, how can we be ready, or at least remember? If the planet has kept ledgers of ice and stone, what have we left for whoever comes after us? The answer is less comforting than we like to think. In Mesopotamia, scribes pressed wedges into damp clay, then stacked their tablets in palace storerooms and temple libraries. They did not intend them to last forever. Many were meant as temporary records, receipts, inventories, letters. But when cities burned, as they often did, the fires that devoured wood and cloth and reed roofs did something paradoxical to the clay. They baked it. Kilns of catastrophe turned fragile mud into ceramic. 4,000 years later, broken but legible, those tablets still speak. Now compare that to the way we store most of our knowledge. The sum of modern civilization's memory, its science, laws, art, gossip, and code, lives on spinning metal disks, silicon chips, magnetic tapes, and flashes of charged states in solid-state drives. Documents float in the cloud, which is really just someone else's server farm. It feels eternal because it is redundant and omnipresent. Until the power goes out, the disks stop spinning, the maintenance budgets vanish. Imagine, as a thought experiment, that humans disappeared tomorrow. No enemy bombs our cities, no one deliberately burns our libraries. We simply stop tending them. Within hours, servers begin to fail as cooling systems shut down. Within days, battery backups are drained. Within months, data centers without active climate control start to corrode and overheat. Magnetic domains on hard drives begin to relax. Flash memory cells leak charge. Within decades, unmaintained storage media become unreadable, even if physically intact. Their formats obsolete, their encoding schemes forgotten. Paper. Acidic office stock yellows and crumbles in a century or two unless kept in special conditions. Glossy photographs fade. Ink runs. Books mold. Microfilm decays. Only the most carefully archived materials, if any, might persist. What does survive 10,000 years of abandonment? Some stone monuments, especially those in dry or cold climates, might endure in recognizable form. The pyramids, Mount Rushmore, large dams and bridge piers, some skyscraper cores stripped of glass and steel. Buried concrete foundations, if not chemically attacked, could persist as odd rock. A few bronze statues might corrode into green husks, but still hint at human figures. Plastics would be everywhere, though not as bottles and bags. They would fragment into smaller and smaller pieces, microplastics lodged in sediments and soils, geological markers of our presence, layers enriched in industrial chemicals, combustion byproducts, and fly ash would show up in cores as the Anthropocene horizon. Radioactive isotopes from nuclear tests and reactors would leave a distinct signature, slowly decaying but still detectable. A future geologist, drilling a core through our strata, would see an abrupt change. A thin layer rich in these novel materials, a spike in carbon dioxide and methane trapped in whatever ice remained, an extinction and redistribution of species as we rearranged ecosystems. They might find strange alloys, odd concretions full of rebar, cavities that looked like tunnels and basements. What they would not find easily are our stories, our equivalent of Gilgamesh. Novels, films, scientific papers, web pages would mostly be gone. A few inscriptions carved in stone, perhaps, on war memorials or at the base of statues. Some engraved plaques, time capsules, etched silicon wafers, if they were encased and lucky. But the vast, teeming, contradictory forest of our thoughts would have vanished almost without trace. From that vantage point, how would they judge us? Standing in the ruins of a collapsed overpass, picking through shattered glass, they might conclude that we were clever primates who learned to chip and melt stone, shape metals, harness fire, and alter our atmosphere. They might see the abrupt proliferation of synthetic compounds and isotopes as evidence of technological flourishing. They might guess at large, energy-hungry societies from the scale of our infrastructure. But unless they found a few preserved caches, vaults in deep mines, devices on the moon, inscriptions in unusually stable environments, they would know almost nothing of our inner life. No Hamlet, no Einstein, no jazz. Our history might be compressed into a few bullet points. Tool-using hominins, agricultural landscapers, industrial modifiers, sudden bottleneck. Realizing this reframes how we look backward. If a civilization as information-dense as ours can, in imagination, become archaeologically thin in a mere 10,000 years, what does that say about the chances of finding rich traces of any cultures that might have risen and fallen 30 or 40,000 years ago? Especially if they clustered along coasts now submerged or built in perishable materials. The usual phrase, "There's no evidence they existed," starts to look less definitive. Absence of evidence, especially in a world repeatedly scoured by ice, flood, fire, and rising seas, is not strong evidence of absence. It is, at best, a statement about the current reach of our spades and sensors. This is not license to believe anything. We still need positive data to support claims, tools in layers, structures in context, chemical signatures that match technologies. But it should temper our arrogance. The silence between cave art and clay tablets may conceal more than idleness. The gaps in our timeline may reflect not only what wasn't there, but what doesn't preserve well, or what we haven't yet known where or how to look for. There is a final irony here. The ancients, writing on clay by necessity, accidentally made some of the most durable information storage ever used. We, with vastly greater means, have built an archive of staggering richness on media that cannot outlast a few centuries without constant care. If we want our own story to survive the way theirs has, we may need to relearn a lesson they never intended to teach. That sometimes, if you want to speak to the deep future, you have to think in stone and fire. And if we accept that our own record is fragile, we may become a little more cautious about underestimating the depths of the past, where stone, ice, and a few mythic echoes are all that remain of worlds that were, in their day, as vivid to their inhabitants as ours is to us. If our archive is fragile and the cosmos indifferent, the obvious question hangs in the air. What happens the next time something big comes our way? For most of the story we've traced, humans could only watch, or fail to watch, as the sky rearranged their world. Now, for the first time, we have a chance to see the shot coming and maybe move out of the way. Scattered across the globe, in modest offices and desert mountaintops and orbiting observatories, a quiet network is learning to do just that. Astronomers call the objects they hunt NEOs, near-Earth objects, asteroids and comets whose orbits bring them close to ours. The job is simple in principle and relentless in practice. Map as many of these bodies as possible, determine their paths, and project whether any might intersect Earth at the wrong time. Survey telescopes like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona scan the night sky in wide sweeps, looking for dots of light that shift position from frame to frame. Software flags candidates. Human and machine eyes refine them. Once an object is confirmed, its orbit is calculated, then refined with additional observations. Space agencies keep catalogs updated. The Minor Planet Center, NASA's CNEOS database, where each rock is assigned a designation and a running estimate of its impact probability. So far, this effort has found tens of thousands of NEOs larger than a few tens of meters. Most are harmless. Their orbits never cross Earth's closely enough to worry about. A smaller subset, potentially hazardous asteroids, are big enough, over 140 meters, and come close enough that, over centuries, gravitational perturbations could put them on a collision course. None of the known ones are currently slated to hit us in the next 100 years, but known is doing a lot of work there. We still miss things. In 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia, with the energy of about 500 kilotons of TNT. It came from the sunward direction, invisible to most ground-based telescopes. The resulting airburst shattered windows and injured over 1,000 people, mostly from flying glass. Tunguska-class objects, 50 to 100 meters wide, are rarer, but not vanishingly so. Statistically, they may hit every few centuries. City destroyers, on the order of 300 to 500 meters, are rarer still. But their impacts would be region-shaping disasters, tsunamis, mass fires, long-lasting economic and climatic effects. Planet killers like the Chicxulub asteroid, 10 kilometers across, are on much longer recurrence timescales, tens of millions of years. We are almost certainly not due for one of those. The realistic risk for our lifetimes and our grandchildren's is in the small to medium range. Blasts that could flatten a city, poison a coastal zone, or throw just enough dust into the stratosphere to dent harvests for a few years. The crucial difference between us and our ancestors is that we are not limited to myth-making after the fact. We can, in principle, turn such an impact into a manageable engineering problem. In 2022, NASA's DART mission, Double Asteroid Redirection Test, deliberately slammed a spacecraft into a small asteroid moonlet, Dimorphos, altering its orbit around its parent body. The change was tiny in absolute terms, but measurable and, more importantly, predicted. It was proof of concept. A kinetic impactor can nudge an asteroid if we hit it early enough. Other deflection ideas are on the table. Gravity tractors, spacecraft that hover near an asteroid using their tiny gravitational pull to tug it over years. Laser ablation, vaporizing surface material to create thrust. Even, as a last resort, carefully targeted nuclear blasts to change trajectories. All rely on one unforgiving condition: time. To move a rock by a planet's radius, a small push applied a decade in advance is far easier than any heroic shove at the last minute. That brings us back to the Taurid stream and other debris bands. Astronomers are beginning to design dedicated surveys, telescopes that focus along these orbital lanes, looking specifically for the larger, darker bodies that might lurk there. Space-based observatories like the planned NEO Surveyor, operating in infrared, will be able to spot warm, dark asteroids that are hard to see from Earth. Each new map we make of the sky's loose stones buys us options. Still, nothing is guaranteed. Budgets can be cut. Priorities can shift. We might miss the one that matters. If that happens, if, say, a 200-meter object explodes over a major city, or a 500-meter rock splashes into an ocean and sends tsunamis racing toward crowded coasts, our digital age could be split into a before and after, as sharply as any Younger Dryas line. Whole regions would be thrown into chaos. Power grids, data centers, undersea cables, fragile, interdependent systems would fail. Even if global civilization didn't collapse, it could buckle. In the centuries after, if rebuilding took different paths, much of our current technological stack might seem like a brief, unsustainable flare. Future descendants, digging through the rubble, might find odd layers of plastic and metal, isolated concrete husks, and radioactive traces. They might tell stories about a time when people flew metal birds in the sky and spoke through invisible nets until the firestar fell and the age of screens ended. They might attribute it to divine judgment or to the return of a long-feared celestial body. They might be wrong in the details, but right in the emotional structure, just as we suspect our flood myths are. Alternatively, imagine we see it coming. An object is found decades out, with a 1 in 100 chance of impact, then 1 in 10, then near certainty. We rally. Telescopes around the world refine the orbit. Nations that barely cooperate on anything else pool resources for a deflection mission, because the alternative is unthinkable. The launch succeeds. The impactor hits. Years later, radar confirms that the asteroid's future path will miss Earth by a comfortable margin. For the people who lived through those years of dread and mobilization, the relief would be profound. Myths might grow around that too, of a time when we pushed aside a demon, when the stone that was coming was turned. Perhaps a child born after would hear of it as a half-legendary near-miss, like an updated version of the Ark story. But this time, the boat was a rocket, and the warning came not from a whispering god, but from a CCD and some math. Either way, whether we avert the next crossing or not, the key shift is that we have agency. We are not Neolithic skywatchers puzzling over omens. We are a species that has begun to measure its environment beyond the atmosphere, to simulate futures not just in story but in code, and to move mass in space deliberately. We cannot choose whether rocks exist. We can perhaps choose whether the next chapter of our own story is written in sudden fire or in quiet, coordinated course corrections. That choice, more than any hidden planet or lost civilization, may be the deepest measure of how far we've come. since the days when we first watched the sky catch fire and had no answer but fear. Seen from the vantage point of planetary defense offices and infrared telescopes, the future looks precarious but not hopeless. To understand what that future sits on, we have to turn and look back one more time along the path we've walked, a 30,000-year trail of fire, ice, drowning coasts, and rising mines, and try, cautiously, to sketch its shape. Some parts of that sketch are drawn with thick, confident lines. Ice cores from Greenland and Antarctica tell us that the climate has not been a gentle backdrop, but a restless protagonist. The Younger Dryas cold snap, beginning about 12,800 years ago and ending around 11,600, shows up there as a dramatic plunge and rebound in temperature. Smaller kinks, the 4.2 kilo-year drought, the mid-6th century chill, are also etched in isotopes and trapped gases. Stratigraphy, layered sediments in lakes, oceans, and riverbanks, confirms shifts in vegetation, flooding, and fire at those same times. Tree rings, counted year by year, register narrow growth in bad summers, sudden improvements in good ones. Genetics adds another firm contour. Our genomes bear the imprint of bottlenecks and expansions. Times when human populations shrank under pressure, then rebounded. Times when previously separate groups mixed, leaving ghost ancestries without clear archaeological correlates. We know, as surely as we can know anything about the deep past, that our species has been squeezed and scattered more than once, that whole lineages disappeared, and that the survivors carry a biased sample of the original diversity. Within those solid frames, more tentative lines appear. The black matte layers, thin bands rich in charcoal, microspherules, nanodiamonds, and platinum, clustered around the Younger Dryas onset, are suggestive, though not undisputed. They could be the fingerprints of widespread wildfires alone, or of wildfires ignited by a cosmic bombardment. Fragments of a disintegrating comet exploding over ice sheets and continents. The Taurid stream, likely the smeared-out remnant of a giant comet, crosses our orbit twice a year. Tunguska and Chelyabinsk stand as modern reminders that even modest pieces of such debris can unleash city-scale energy. Sites like Gobekli Tepe, with their megalithic enclosures built by nominal hunter-gatherers right at the end of the Younger Dryas, look like responses to upheaval, architectural assertions of order and meaning in a just stabilizing world. Other megalithic traditions, with alignments to solstices, lunar standstills, and perhaps slower cycles, suggest a long, patient project of sky watching, maybe born of a desire not just to time harvests, but to foresee when the heavens might misbehave again. Underwater and on continental shelves, bathymetric maps reveal drowned river systems and plains. Doggerland, the Sunda Shelf, the Persian Gulf Basin, that would have been prime territory as the Ice Age waned. A few underwater finds, Mesolithic tools at Boldner Cliff, submerged walls off Heliki, debated structures near India's coasts, hint at the richness that might lie beneath waves. Oral traditions of sunken lands, Atlantis, Aztlan, Kumari Kandam, may compress centuries of incremental sea level rise and sudden storms into single, nightmarish drownings. Megalithic masonry from Peru to the Mediterranean, with its polygonal fits and seismic-resistant designs, tells us that stone-working knowledge was deeper and more experimental than isolated masterpieces suggest. Myths of culture bringers, Thoth, Quetzalcoatl, Viracocha, Owans, encode a pattern of strangers teaching core skills after times of chaos, perhaps rooted in real movements of knowledge keepers fleeing failing centers. And then there is the realm of speculation, where the lines are dotted or better left penciled. The idea of a single globally connected high-technology civilization before Sumer, complete with electronics, factories, or spaceflight, has no hard evidence. No unambiguous pre-Holocene artifacts of that kind have been found. If such a civilization existed, it left remarkably little in the way of durable traces. What we do have are anomalies. Dates pushed earlier than expected for certain behaviors, sites that seem too sophisticated for their official slot, occasional out-of-place finds later debunked or still unresolved. They invite curiosity, not confident narratives. Between those extremes, a picture emerges that is neither the tidy staircase of old textbooks nor the world-spanning Atlantean fantasy. It looks more like a rough, multi-leveled landscape of rises and falls. Modern humans spread out of Africa, adapt to many environments, and develop symbolic culture. They endure climate swings, eruptions, and local disasters. Between 30,000 and 15,000 years ago, they experiment with complex tools and social networks across Eurasia, Africa, Australia, and the Americas. Then the end of the Ice Age accelerates, culminating in the Younger Dryas shock, whatever its exact trigger. In the centuries and millennia after that shock, as the climate stabilizes into the Holocene and seas climb, humans respond with bursts of innovation, monumental ritual centers, domestication of plants and animals in multiple regions, expansion into deglaciated lands, new forms of trade and hierarchy. Along coasts now drowned, likely there were early dense settlements whose stories we have mostly lost. Inland, a more durable ground, some of those experiments hardened into the first city-states, writing systems, and codified laws. Through it all, our ancestors tell stories. They remember floods and fires, dimmed suns and falling stars, strangers who came from the sea bringing knowledge. They personify cosmic forces as councils of gods. They encode practical sky scans in sacred architecture. They turn the trauma of real drownings into myths of Atlantis and deluges. Their brains, shaped by long exposure to risk, are hypervigilant for patterns, eager to link celestial events with earthly fate. We, much later, inherit both the physical fragments and the stories. We add our own layers of interpretation: Enlightenment skepticism, scientific models, speculative fiction, conspiracy theories. We project our current fears about secrecy, technological hubris, ecological fragility, back onto Nibiru, the Anunnaki, lost continents. In doing so, we sometimes obscure the quieter, more human truths. That early scribes were bureaucrats as much as theologians. That stone circles were calendars as much as temples. That floods can come from melting ice as much as from wrath. Reassembling the broken timeline doesn't yield a single aha explanation. It gives us instead a richer, messier tapestry. Ice cores alongside epics, pollen grains next to king lists, nano-diamonds paired with flood myths. Some threads are bright and certain, others faint and frayed. There are holes we may never fill. But the gap is no longer featureless. Shapes are emerging in the fog. Vanished coasts, fire-streaked skies, hilltop sanctuaries, bands of teachers moving through a bruised world. Our task is not to flatten those shapes into one grand story, but to let them coexist, layered and partial, and to keep refining them as new data arrives. In that humility, holding ice and legend, gene and stone in the same frame, we may finally be approaching a kind of understanding that neither our ancestors with their myths nor we with our models could reach alone. The history gap becomes less an absence, more a dimly lit corridor full of echoes, leading from the last days of mammoths to the first cities, and beyond, to us, standing here, still trying to remember. At the beginning of this journey, We stood on an anonymous shore and watched the sky catch fire. A wall of water rose where no sea should be. Constellations fell like burning snow. It felt like myth, a nightmare tableau stitched from religious texts and disaster movies. Now, after walking back and forth across 30,000 years of ice and ash, drowned valleys and stone circles, we can imagine days like that not as pure fantasy, but as the tail end of real chains of events. A comet fragmenting far from the sun, a cluster of its shards intersecting our orbit, air detonating over an ice sheet, shock waves and meltwater and fire rolling outward. We know, in a way our distant ancestors could not, how such a day would look in multiple registers at once. In the sky, blinding bolides, a veil of dust and smoke. In the rocks, a thin, dark layer rich in charcoal, microspherules, odd isotopes. In the ice, a sudden jump in dust and nitrates, a kink in oxygen ratios as temperatures buckle. In the living world, forests burned or frozen, giants vanishing from the record, people on every continent forced to shift their ways of life. We also know something they perhaps felt but could not articulate, that the planet does not remember such days as we do. For Earth, catastrophe is just another entry in the ledger, another line in the log of energy flows and phase changes. Only in us does it become judgment, omen, story. That, in the end, may be the deepest secret this long detour has revealed. Not that aliens came to mine our gold. Not that a rogue planet is hiding behind the sun, waiting on a 3,600-year schedule. But that we, the fragile, anxious apes who tell those stories, have already come through more than one bottleneck. We are the descendants of those who stood under strangely dimmed suns, who watched coasts disappear and snows come early, who saw familiar animals die off and unfamiliar stars rise where none had been the year before. Our myths of floods and lost lands, of fire from heaven and culture bringers from the sea, are not evidence of one monolithic, lost supercivilization. They are evidence of something in some ways more astonishing. That bands of hunter-gatherers, small farming villages, and early city dwellers witnessed pieces of planetary violence, survived, and cared enough to pass their fear and their learning forward for hundreds of generations. We carry that inheritance in our nervous systems. The same hyperactive pattern-seeking that once helped a child notice a strange red tint to the sun before the frost comes now makes another child fall down an online rabbit hole about Nibiru. The same drive to anchor time in the sky that led a priest to carve solstice alignments into stone now leads an astronomer to code orbital simulations. The same impulse to apportion blame to gods for misfortune now tempts us to see malice or conspiracy behind every tremor in the data. But alongside the fear sits something else, a track record of endurance and adaptation. Standing on this side of the 30,000-year gap, we can see that humans did not just hunker down and wait for better weather. They invented new tools, new foods, new ways to live together. They turned the trauma of nearly ending into incentives to watch more closely, to plan further ahead, to cooperate at larger scales, to invest in institutions, priesthoods and scribal schools then, scientific agencies and telescopic surveys now, that extend individual perception across time and space. If we take seriously the idea that we are children of catastrophe, the question stops being, when will the next rock hit? And becomes, who will we be when it does? We can choose to react as we mostly have in the past, after the fact, with myth-making and partial memory, rebuilding in the same vulnerable places with slightly different names. Or we can decide, collectively, that knowing even a little about the mechanics of fire and ice obliges us to act differently, That might mean persisting with the unglamorous work of mapping near-Earth objects, funding climate models, and drilling ice cores, even when no immediate crisis looms. It might mean designing cities and infrastructures with redundancy and retreat in mind, accepting that coasts move and rivers change. It might mean building archives in more durable forms, etched stone, distributed repositories, that could speak even if our grids go dark for a time. It also means tending to the stories we tell. We will always have myths. They are part of how our pattern-seeking brains metabolize uncertainty. The choice is whether those myths paralyze us with fatalism or galvanize us toward stewardship. We can cling to tales in which we are pawns of capricious gods or indifferent aliens, or we can start telling ones in which we are apprentices who have finally begun to understand the workshop we were born into. The wall of water and the burning sky are, for now, images from the deep past and from our speculative fears. But they are also reminders of a more general truth, that stability is precious and rare, that our current warm interval and technological plateau are not guaranteed. We have somehow made it this far through cycles of fire and flood, carrying with us not just the scars, but the tools those cycles forged. What we do with that inheritance, whether we use it to become better ancestors than we had any right to be, or squander it in denial and distraction, is the unfinished part of the story. The clay tablets and ice layers of the future, if anyone reads them, will record the outcome in their own indifferent way. The myths, if any are told, will do what they have always done, turn the blunt facts of survival and loss into meaning. Standing between those two archives, aware for perhaps the first time of both, we have a brief, extraordinary chance to choose the kind of memory we will leave behind. Not just of fire that fell on us, but of how we learned, finally, to see it coming and to light a different kind of flame.